You're listening to Coding Blocks, episode 94. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
And you can head to codingblocks.net and find show notes, examples, discussions, and a lot of other things.
That was way more animated than I expected. Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks or head to www.codingblocks.net. Find all our social links there at the top of the page. With that, I'm Alan Underwood.
I'm Joe Zach, and I'm super hyped.
And I'm Michael Outlaw, and I'm not quite on as much caffeine as Joe apparently is.
Woo!
Right.
Or maybe it's Halloween candy. Maybe you're still coming down from Halloween.
Everybody understands that. All right, so as we like to do, we want to lead in with a bit of our, hey, we took something out here, of our news. And first is we'd like to thank people for the reviews that you leave. So in iTunes, I've got Press Lisa, Tekanda, Raj, Ags, Hearts, LJKH.
Yeah, and over in Stitcher, big thanks to Scott V, Hot Garbage, Bitsui, Green Plane, MP Daves, Joe's the Best, Steven C. Wise, Zool303, and one more here. Let's see, drum roll, please.
Wait, how do you pronounce it? Let's see. This is a
Michael Tippett.
Michael. That's always the hardest name.
Yep. So big thank you, all you guys. I recognize some names from Slack there. So big thanks. We really appreciate it.
Yep.
And one other thing I wanted to mention real quick is I managed to scam myself onto the weekly dev tips. So if you're not familiar with that show, it's like a quick 5-minute or so tips brought to you by Steve Smith, aka R. Dallas. And I'm on episode 31. So I have a link to that episode in the show notes, but really you should just go subscribe to the show because it's awesome. And it's only 5 minutes, which is very different from what we do.
Hey. This one might be a little bit shorter than our previous 2 hour and 45-minute one. So,
We'll see.
Have you guys ever noticed that like programmer jokes are now like synonymous with dad jokes? Or maybe they always were and we just didn't want to admit to it. But I've got a couple, like you could either refer to them as programmer jokes or dad jokes. But I've got a couple coming from the Slack that I thought I'd share with you. So the first one from on Slack, Micro G. Did you hear about the programmer adventure movie?
No.
On in the arguments.
Oh man.
Thank you. I'll be here all the week.
That was good. Micro G is awesome, by the way. All right, yep. Keep going. You said you got another one, right?
Oh no, I thought I'd sprinkle it in throughout.
Oh, okay, throughout.
Okay, all right. Stay tuned. All right. Well, today we're going to be talking about data structures, and we kind of planned on diving in there with like arrays and linked lists and kind of looking at stuff. But what we kind of found is it's kind of hard to talk about some of that stuff without first talking about primitives. So we're going to do a little bit of focusing on that today, but we still want to kind of hit the highlights of data structures. And I think it's important to talk about data structures, particularly because we talked about algorithms, and they're both like really instrumental and huge parts of kind of computer science. Like those two things kind of go together. But it's kind of funny to me. Like I keep thinking about data structures and algorithms as always living together, but it kind of feels like there's more to our day jobs than that. Like those are parts of it. But if you were to say that there's 3 parts or 4 parts or more parts, what would those other parts be?
To the day job?
Yeah. Like if you had to, go speak to somebody, say a class full of college students and say, hey, listen, you got to know your data structures, you got to know your algorithms, and you got to know
how to name stuff.
Say get
communication, man. I honestly, I think communications. I don't think this is what you're going for, but
yeah. I just wondered. It's like I was trying to think of like if it felt like there should be one more word. It's like these are the tent poles, and there should be at least one. I felt like I should say there are data structures, there are algorithms, and there are working with libraries, there are ticket systems, there's Jira. Like, is there a word for all of that stuff? Is it just communication?
Problem solving.
Ticket juggling. Yeah, I like that one. You said that.
It's like dealing with crap.
Constant learning, right? Like, I don't know. There's so much. It's
I feel like there's a despair poster in here somewhere, like passing the book.
Yeah, I spent a huge part of the day just reading through docs, but like that's not covered by data structures and algorithms, but it feels like it ought to be in there somewhere.
Yeah, we've joked about it in the past, right? Like you see all these movies where there's people just hacking away on keyboards, and we're like, that's not real.
Yeah, and they're definitely not data structuring.
No, they're not data structuring.
Well, honestly, like, I can tell you, like, whenever we talked about the algorithms, like, I kept feeling like I wanted to say that I thought data structures were more important. And I don't know that it's really fair to compare that, but it seems like I do a lot more thinking about data structures in my day-to-day life as a programmer than I do thinking about algorithms.
Well, it's a part of your algorithm, right? Typically, it's, do I store this as an array? Do I store it as a hash table? Do I store it as whatever? And they all have big implications on how your algorithm actually turns out. I'll be able to speak at some point tonight.
Yeah, I guess so. I guess I'm conflating like algorithms and like big O type stuff because I just don't really sit down and think like, what's the runtime of this algorithm? But I do think like, oh, you know what? I should do this as a hash table because I'm going to be referencing and looking these things up frequently by their name or some sort of key. So I don't want to do this in an array, which is I know is going to be slow.
Yeah.
Okay. Anyway, just wanted to kind of
bad because I don't think about it. So I guess I'm supposed to like list everything and you're done.
Yeah. It is pretty annoying to look stuff up in arrays. So I always notice when things are in arrays and I don't want them to be. So like filter through them or something.
You know where I find that I think about these things a lot because they're so limited in the data structures available is in JavaScript.
Yeah.
Right? If I need to look up an item directly by a key, there's no question how I'm doing it. I'm not putting it in an array, but you're very limited in your choices, so you don't really have to think that hard about it.
Yeah, I do a lot of transforming in JavaScript, seems like. So I'll get something out as an array, I'll get it as an object, and I need to just kind of change it to another format. And so it seems like I'm doing a lot of like mappy type stuff, or I'm always Googling how to like loop through the keys in an object.
Yeah, I'd agree.
We're going to be talking about those in a little bit, and we're going to be talking about JavaScript and a couple other languages. So we've got a great episode in store for you. But I want to mention a few more things about data structures before we go on. First, we didn't really kind of define what the data structure is. And when I say data structure, what I mean is specifically like the Wikipedia kind of definition here, which is how we store and interact with data in our programs.
Yeah.
Yeah. That's like kind of a weird definition because like if I just assign something to a variable, then I'm storing data, aren't I? If I'm writing to a file, I'm storing data.
You definitely are, but I don't think writing to a file is typically what they're talking about, right? I mean, it's going to be more the built-in types you interact with.
Yeah, I just thought it's kind of a weird way of putting it. Ultimately, like it's about how you kind of organize your data, right? So even if you're talking about storing it on disk in a file, how you store it, whether it's in JSON or a CSV or something like those are kind of like data structures, right?
Yeah, I was going to say like I could actually see where I would have thought about it like in the past, when we talked about data structures, I would be far less concerned with like the variable type until it became a problem as opposed to like how I was going to persist it to disk, right? So if I was going to have some structure of a file format, right? Then in my head, I might think of that as like a data structure, albeit a custom one, but I might be more concerned with that, if that makes sense.
Yeah. And what if you're writing a time series database? Like you're probably going to think a lot about how you persist that data to disk, right? I bring that, but we just read an article.
Like any kind of database, you might be thinking about how you're going to persist it to disk.
But my question is though, like, are we going off the rails here, talking about data structures and how they're stored versus what a data structure in a programming language is?
Oh yeah, right? For sure.
Okay,
they
good.
Go hand in hand.
Yeah. Sort of like I don't see JSON as a data structure. I see it as a way to represent structures of data. You know what I mean? Like
it's like a format.
Yeah, it's how you're storing information about what the types of data in it are, whether it's an object or an array or a string or whatever. So to me, that's just storing what you're going to turn back into a data structure that a programming language understands at some point.
I would say it's still a data structure but it's at a higher level. Like it's like a composite data structure. Like I realize in the JSON extreme, like you're just talking about a string of characters, right? And you're gonna be like, well, no, you can't talk about that. But like if you were to abstract that more loosely, like into the object that it actually represents, right? So then you have objects nested within objects, or whatever. That would be that collective would be a data structure, right? the thing that the JSON is describing.
It's structured data. It's not a data structure to me, or data structure. You know what I mean? Like, yeah. Like what I
guess
think
what
about,
I'm saying is like there's data structures as like at the primitive level, but then there's also like complex things like objects, which are still data structures, like a list, an array, and heaps and queues and stacks.
and I agree with that, but I wouldn't say that JSON or XML is that.
Well,
Those
I
are
meant
just
that I
ways
was
to.
referring to like the objects that the JSON was describing.
Okay, yeah, fair. That's what I was getting at, and that's why when like Joe had mentioned about storing it on a disk or anything like that, to me that's not data structures. That's just structured data stored on a drive somewhere. It's
Well,
when
what
it's
about like, okay, but fair enough. But I mean, like the example that I was thinking of in my head was like, what if you were writing the data to the disk in a particular file format? Like if you were writing an MP3 by hand to disk, right? There's a very specific structure that file has to be written in. You know, there's going to be a header portion, you know, that's going to be reserved for certain parts, and then the music's going to start, blah, 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 right? If you were to write a Word document, you know, by hand to disk, right, you would have a certain part of the header that's going to be reserved for like metadata about the file, things like that, right? That's the kind of thing I was thinking of when I was saying like writing something to disk as a data structure.
so. I guess where I'm like at least mentally drawing the line for me is totally like you're representing the data structure in a file format or in some sort of written format, but that's not the data structure. It doesn't turn into a data structure until you materialize it or marshal it back into something that the programming language is using, right? So it looks like you can look at a JSON notation or JSON string and know that, oh, okay, that's going to be an object with an array and some strings and some numbers, but not until that thing is actually deserialized or put back into the language where it's used is it a data structure. It's just a string or binary representation of what that data structure will be at some point. So I guess that's kind of where, like, for me, I'm drawing the line between what a data structure is and just formatted structures of data.
Yeah, I definitely think there's a kind of division there between like how it's stored and whether an object in x64 and binary, depending on how you encode it, is still kind of the same object, right? It's still the same data structure to me. However, I do think there are a couple of gray areas. Like we've talked about inverted indexes before and how sometimes they'll actually store an index backwards in order to make certain kind of like clauses, match. And also there's an example a couple of years ago where Blizzard Entertainment used to store your passwords. They would store your password, and they also I think they would lowercase the whole thing just to kind of get around people's password typos, and they would do the hash of the lowercase just to kind of make passwords a little bit easier. So they're still hashing and everything, but they would just kind of do a little bit of trick. And I kind of think of that as a little bit data structure-y. But yeah, I'm definitely cheating. So I threw a curveball trying to knock us off the rails because I kind of wanted to think about things at a level like that where, so many times when people talk about data structures, they think about arrays and linked lists, and those are data structures. But so is a class that you create, right? Where you say, these are the top level and this is an inner class and here's an array. Like I just created a data structure.
Just a very specific one.
I guess not to harp on the storage part of it, but even like how you like quote store it in memory, right, is kind of where I was thinking like the storage does matter.
Oh, it does. It definitely does. I just think that at that point you're talking about the data itself as opposed to the data structure.
Well, either way, it's the data itself. It's just whether the data is in memory or on disk. But yeah, I don't want to harp on. Well, it'll make more sense when we get to my specific example.
Okay.
All right. Well, we'll get there, and
maybe it will make more sense. No promises. No pressure.
Yeah, if you've made it to episode 93, hopefully this isn't your first. If you made it this far, then you know what to expect, right?
But this is 94. Yeah. So 94. If you made it there, then you've also like gone into the future now, and you're in a later episode.
Or another way to interpret that is if you've made it to episode 93, you have this one yet to listen to.
That's right. And maybe off by one.
Yeah, you're in the zero index range. I got it.
Yeah, exactly.
All right.
Exactly. Data structures you use have a big impact on resources. So, things like CPU time to complete, memory, disk space, all that sort of stuff. And different languages often have built-in support for data structures. So like C has arrays that are built into the language, right? It's actually a part of the syntax. It's got those cute little indexes and everything, and how you arrange it is different. Like you can't easily write a true array in like a C# or a JavaScript. Like you can't create the underlying data structure in order to kind of meet the traditional definition of an array. And so some of these languages have built in support for these data structures that are really nice. And there's also more complex ones that are obviously composed of different various pieces.
Hey, I'm curious. How do you say C# you can't represent the array?
So we should do a full episode on arrays and other linked lists, but the kind of the traditional definition of an array that I think about is basically a contiguous block of memory that has a fixed size per index, and that lets you do like different kind of math in order to get to like the 50th element or something like that.
So you were talking about the storage behind the scenes.
Yeah, like you can't do that without allocating memory, because you have to do like a fixed length. You have to know the length of the array, ahead, and you need that memory to be exactly in that location. And if you try to create your own, you basically have to do some sort of malloc. And so maybe C# has some sort of stuff where you can just kind of like allocate a certain block of memory this size and start chunking it up and maintaining it yourself. But JavaScript, no way.
Okay. Yeah, that's what I was curious about, because the syntax is basically the same, but you're saying that the underlying implementation of how it's handled is not. Okay.
Yep. And we'll actually we're going to talk a little bit about some specific languages coming up here, and we've got some really interesting stuff. I think it's really interesting to talk about, specifically with JavaScript arrays and how they work under the covers. And sometimes an array is not an array, and sometimes it is. So hopefully you'll find that as interesting as I do. Yeah, JavaScript. Everything's crazy.
Right.
Everything you learned, throw it out the window.
That's right. I do like your next question here, the last one.
I don't know where I am in the notes anymore. Are you talking about the one about how would you build an array in SQL?
Yes.
Yeah, I mean, it's a programming language, right?
Isn't it just a table?
Well, I mean, is the table contiguous in memory?
Well, see, now you're going to implementation. So,
Yeah.
No, probably not.
Yeah, so that's kind of interesting. And I mean, JavaScript has an array that's, you can put, the keys could be letters and all sorts of other weird stuff, could be objects. So, they certainly think it's an array. They call it an array. If you do a type of or whatever, a type, they'll tell you it's an array. So I don't know. There's a lot of gray area, and we're going to examine some of that up close. And got a couple, we already mentioned a bunch of different examples, but some basic ones like arrays and linked lists. And then you get in kind of more advanced type stuff like trees and tries and hash tables and heaps. And that's kind of the traditional stuff that we think about when we talk about data structures. But there's also a couple of things we've talked about like on the show, like the inverted index for search engines. And I'm trying to remember a couple others, but there's a couple other data structures that are less common, but still not unheard of. Some pretty cool ones out there. And also, it's just you create your own kind of data structure. That's definitely outside the kind of normal definition, but I think it still applies. Like the way you structure your data and your classes is definitely going to have an effect on your CPU, memory, and disk space, and it's definitely organizing your data.
Did any of you guys, did you ever do like programming back when, like think back to like C++ kind of days, very struct heavy, where like the position of it actually mattered, like if you were reading a memory stream, I mean, you could do it today. I'm not saying that like you can't do the same type of program today. It is done today. But, if you were to read in a stream, you're like, okay, this byte through this byte represents this part, and, this bit represents this, that kind of thing. You know what I'm talking about?
It's been a while. It's
definitely kind of stream heavy, but but it doesn't have to be though too. I mean, like you could. I've definitely been involved in projects long ago where we would have structures. We would literally have a struct, that would represent what the data was, and we might write that out to a queue. We might write that out to file and then read it back in. But
yeah, I would imagine if anybody's doing like video, audio type stuff, FaceTime, I would imagine that they still deal with that stuff a lot, right? Because now you're dealing with buffers and trying to make sure things come in, you don't fill up, you don't blow up the memory, all that kind of stuff. And that's very much there. And data structures are going to matter a ton.
The kind of the main one that I was thinking about though would be like any kind of network.
Oh yeah,
you're
that
just
too.
Oh,
writing
yeah.
from a socket, right? Like if you're at the lowest level, right? Like I'm not saying you got some framework on top of it that you're taking advantage of, but if you're actually like writing that framework, then you might care more about that.
Yeah, because the first few bytes tell you something about the network traffic, and the next part's a bit of the packet. Yeah, I mean, it, if you're doing hardware level programming, and actually, what's funny? I've got a buddy that worked at AWS or still does work at AWS, and he was writing the software drivers for the low level hardware of the networking, basically trying to find the fastest routes between different places. I mean, they have a bunch of PhDs with math degrees, trying to figure out the best ways, and they have to implement those things because they buy commodity hardware, right? That's the thing in the cloud is, hey, we buy a bunch of cheap hardware, we'll make it run fast, but there's a lot of implementation that goes on underneath the covers on that stuff. So pretty interesting.
Yeah, if you've ever seen like code for old video games like Pac-Man and stuff, it actually have kind of designated regions for like the ghosts. And so if you ever saw like a glitch where sometimes like some sort of memory would get written over part of the image and you would start seeing like text in the arcade game or whatever, that's pretty cool.
That was actually like, wasn't there like I forget what level it was on Pac-Man, but there was like a special Pac-Man level where it like was an overrun error. And
Yeah,
you couldn't see the full screen, but the parts of the screen you could see were kind of scrambled, and you could still play it and solve it.
yeah, and you get to it's the theoretical high score. Like you can get to the very end, like eventually it just crashes. But yeah, they get the last couple points. It was in Ready Player One.
That's what I was going to say. Wait, does this mean that Ready Player One lied about beating Pac-Man? Right?
Well, the movie was definitely a liar, but we shouldn't go there.
Yeah, the movie was not the book. Go
I
ahead.
don't remember this reference in the movie.
It's not in the movie. So that's
in the movie. Okay.
Yeah, that's the thing. Like if you go back and read the book or listen to the audiobook, because it's really good. It's Will Wheaton, right? Reads it.
Yep, President Wheaton.
Yeah, really good. All the challenges in the movie were different. All of them. So,
but it's been so long since I've read that book, though. I don't remember it.
Yeah. So all right,
never mind.
Yeah. Digressing. Oh, the train is way off the tracks now.
Yeah, it is.
Yeah, so I got a couple of questions in here. So we already kind of touched on them, like whether data structure are more important than algorithms. Not for interviewing, I don't think, but for day to day, I feel like it is.
Equally.
It's so surprising.
Really?
Yeah, I'm so surprised that you got like. I mean, I was kind of half joking when I said like, no, I make everything a list and worry about it later. But I'm kind of like not. I'm kind of like,
right?
No, man. Like, it's not a problem until it is, and then focus on it.
Well,
like, if you created a list, if you used a list when you should have used an array, like everything's fast for small n, right? So you're not going to know. It's not a problem until it becomes a problem. That's when you realize, like, oh yeah, I should have used an array instead.
So you're talking about like micro optimization type stuff.
Yeah, like changing your data structure seems super micro optimization.
Well,
for me, it's not so much about performance as it is about me being able to easily use it. Like if I need to look up a key in an array, it's annoying. I've got to do a filter or something, or I've got to loop through to find it. If I have to do that a couple of times, like I feel it. But in a hash table, it just kind of flows easily. So it's like the shape of the object kind of represents, or at least it feels kind of intuitive to me as to how it operates underneath. So if I keep looking stuff up in an array, I'm going to change it or else I'm going to create a copy of it that's a hash for those faster lookups. Otherwise, it just drives me nuts.
Okay, let me rephrase that. You're going to have like your handful of things that you're going to commonly use. If you need it to be an associative array, you're going to use something like a hash table or a dictionary. If it doesn't, then that's where I'm just like, fine, list.
Well,
yeah.
You know what's funny is a little background information when we were putting the notes together. I didn't know there was a linked list in C#, right? Like, because just what Outlaw said, use a list.
Yeah.
You don't think about linked lists.
You don't even think about arrays anymore in C#.
No, not really, because they make it so easy to sort of ignore it, and you're held back by the arrays. But
that's my point.
Yeah.
That's exactly my point. Like if you let's pick on C# for a moment. If you needed to store something in an array-like function, like or a list of something, it's so easy to use list in C# that that's the default go-to until you realize, oh, dang, I actually need to be using an array. Like, we talked about cases where you need to change the underlying list as you're iterating through it, right? You can't do that in a for each, right? So, maybe you want to work with an array in that case. Like, yeah, that's what I mean when I say, like, I don't think about the data structure. So I would say the algorithm is far more important than the data structure.
That's fair. In 98% of the time. Yeah, that's probably, that's a fair assessment.
But what about something like a tree where you've got some data that, like, the data is a tree, but for some reason it's got it modeled in a weird way where you kind of got to like go to a list and look up another list, go to a list to look up another list. And, that's really painful to me. Yeah,
that's different. So we've talked about that before. This was in the handbook. What was the name of it?
The Imposter's Handbook.
The Imposter's Handbook. Being able to identify what something actually is, right? And so what you're talking about is basically somebody implemented something wrong because they didn't understand that they were looking at a tree versus a graph, right? Like a directed graph. So those kind of things, yes, super painful. And that's where I guess that's that 2% of the time where it actually matters as much, if not more than your algorithm, because just trying to even get data into and out of the thing is just really hard.
And I think even still, like, if I'm having a hard time doing a lot of lookups, like I think my brain just naturally wants to kind of get it into a format that I like better first. And so I kind of like the idea of like having a function like, or not necessarily a function, but a process. So like the first part is just like getting the input, transforming it to a convenient way. And the second step, I want to be the logic. And the third, I want to be like formatting an output. It really irks me when I see code that mixes those first two. So where it's like, it gets part of the data and it starts going through and it's like goes out piecemeal and grabs another part, grabs another part, grabs another part. Like I much prefer to have like all my input stuff in one step.
That makes sense.
Yeah. I mean, like taking a more simple kind of example here would be like you use an int to represent a Boolean when you really just could have used it as a Boolean, right? Like either in any of these examples we're talking about, like you picked the wrong data type.
Yep. And those bug me. Those actually do bother me. Like if somebody chooses an int over a Boolean, I'm like, why?
Yeah.
Do that.
There's some other like minor stuff too. Like I'll be working with like I was working with Gatsby recently, and I don't know why. I need to figure out the real root cause here. But my dates were getting serialized to strings when I was doing the GraphQL stuff, and so I would get it in my views, and it would be really annoying to me because I would have these dates. And so one way I could have done it is just down in the view. I could have put my little brackets there, did the date, and then did a new date, and then formatted from there. But instead, I chose to do like a map above the render and just convert all the dates right there. And then later down in the view code, I just wasn't, I didn't have to do any formatting. It was already done in this other step. So I like to do my transforming just kind of outside. That's just a preference, but
yeah.
I think Uncle Bob would appreciate it.
I think
yeah.
Because in your view is just, doing the view code. It's not trying to translate the data, right?
Yeah. I think you'd be on board with that. I think I would be happier if I did even more of that, if I recognized the times I was doing that kind of piecemeal grab out type stuff. Sometimes you'll see that with a query, like you'll do some sort of query and you'll start looping through the query and then you'll run out and grab other stuff. Like I don't like that mixed with the output. Like I kind of like you said about the format, like I'd love to just get that stuff arranged. And then if I want to export it as JSON or CSV or whatever, like let that be its own kind of format output step.
So I agree with the format output, but like to a certain level, I would rather have the data in the proper structure at the right place. And then in the view, you can say, hey, format this date however I want it to, right? Month, a year, or give me the time on it. Don't do that up above it. Let that data flow through in the proper format, in the proper structure, and then handle the view however you need to. Right?
Well, that's still happening in what he was describing, though. But in this case, proper structure equals a date type and not a string.
Right.
And once you have it in your view on that date type, you could say like, "Hey, I just give me the year."
Format it. Right.
Right.
Yep.
Yeah, I think an example like when I used to work in Cold Fusion, and you would basically do the old school style. Like you do a big CF query at the top, you get your data back, and then down in there you would like CF loop over, and you could do little lines of code in there to kind of transform your data or whatever. And I think back then, I'm sure I just did the loop, and then there would be like 10 lines of Cold Fusion stuff underneath, kind of transforming it. But if I were coding it now, I think like my inclination would be to like go ahead and do the transform up there in the top of the page, the CF query, and then keep my HTML dumb just because I don't want to see all that stuff messing with my brain. I don't want to like mess up the display to declarative HTML code with all my crazy logic, weird formatting stuff.
Hey, I'm just going to throw out there you're doing your Cold Fusion wrong because you should have been using a CF module or CF object. I'm just saying.
And a CF module is awesome, man.
That's a throwback.
Yeah, I still don't know about those crazy Fusebox framework stuff. Like, gotta have like 5 files to do anything.
That's been a few years. Hey, so you actually have something here that I think is kind of interesting. I'm really curious where you guys go with this. What are the major tent poles of programming? Are they data structures, algorithms, API persistence? What's the most important to you guys?
I mean, I think the API persistence stuff is, once again, it's like that's where I spend my time. So, I think algorithms, I think about the least, data structures, I think about more. But when it comes down to it, like ultimately that communication, API, that organization stuff, I think is the stuff that I struggle with and think more about.
Man, I'm gonna be way more pragmatic. Because more often than not, you're thinking about like your libraries, your tools, like that. That's where a lot of your time is spent. I think, like just knowing, like because I don't think about, hey, am I going to store this as a Boolean or an array or a hash table? Like that thought doesn't occur to me that often. But like, oh, hey, this namespace has the features that I need for that. Oh, hey, there's this other cool namespace. Like how many times? Honestly, how many times does that happen? Regardless of the language, be it a C# or a JavaScript, you learn about some new library. And you're like, oh my God, that's now a thing? That's amazing. Like that's the type of thing. Those are the APIs, that we think about.
Yeah, if you really know your framework, it's like, should this be a hook? Should this be as part of the router? Should this be part of the whatever? Like knowing the best place to do stuff and the proper patterns for what you want to do could save you a lot of work and a lot of headache.
You know what? On that, so I want to go back to that real quick, but I'll say for me, the tent poles of programming for me is domain-driven design actually made so much sense to me. Like, don't program from your database. Program for your business case. Program for the use case. Like, to me, that's the one thing that I don't think is one of the pillars of programming, but should be taught more, right?
Mm-hmm.
Write code to the case that it's being done because then everybody can understand it. But so what did you just say that I've already lost it? What were you just talking about?
Cold Fusion?
No, not the Cold Fusion.
You're talking about like with the libraries and
the libraries. Yes, that's so. One thing I was going to say, what you said was so important is if you know your framework, then you'll know whether or not you should choose to use a hook or something like that, right? If you're using a library, you don't have to be, it's not like you have to memorize the whole thing at once, but go through the documentation and skim every single page. Just skim it, because then something will stick in your head so that later you're like, oh, I saw something, right? There was something that stuck out and I'll know to go back and look for it, right? I know I do that with just about any framework.
Build a mental index of the documentation so that you know where to go.
It just tickles your mind, right? You're like, hey, wait a second. I remember seeing something about this. I need to go back and look at it, right?
Yeah, I mean, like an example, a great example of this, though, that I think of when you think about like if you didn't know the framework and how it would be like form binding, right? Like if you didn't know, oh, hey, there's this way that you could just bind the data structure straight to the form, and instead you start wiring up controllers to handle all of that for you, right? Like you just wasted a lot of time and code, right?
Yep, and I did back in the day. When you were talking about when you were talking about Cold Fusion, like in Cold Fusion, that was back when, if you think of ASP or even PHP, which I'm not as familiar with the newer frameworks and stuff. But you wrote your HTML and then you mixed a bunch of server-side code into it, right? To write the additional HTML you needed. So there was no such thing as form binding. You wrote an HTML form and then you wrote JavaScript or whatever to handle it. And when I moved over into the .NET world, I carried that pattern with me because that's what I understood, not knowing about the binding, right? Like not knowing that you could have a form on there and just be like, hey, bind this to a data. What? I didn't know that was real. So, yeah.
And we talked about how that first language can really have a big influence on the rest of your programming habits.
Oh, yeah.
Yeah, I'm still cold fusion programming and
all these years later. This running with the rollback. I was listening to an episode of the rollback, and I think it was Chris was talking about how to read a book. And it's funny. There's a book called How to Read a Book. It's like 400 pages, but basically it kind of boiled down to. I just read the summary of it. Was first you kind of go through and you skim, and you're supposed to kind of highlight the things that catch your interest, and then later you kind of go back and you really focus on those things that you highlighted, and you kind of drill in from there. But the idea is kind of like you said, Alan, where it's like first you kind of need to get a lay of the land. Otherwise, if you always kind of like stick in chapters 1, 2, 3 of the book or whatever, you kind of don't see the whole thing before you get started, and you could be missing big chunks of the big picture and be doing things in an inefficient way.
Man, that sounds good for technical books. I don't know about for like reading for pleasure though.
Yeah, definitely not.
So you're saying that for technical books, you should not try to read it from cover to cover.
No, read it, like kind of skim it cover to cover. I haven't actually tried this, by the way. This is an idea, but just don't try to focus on every word. Like if you're having a hard time with something, just kind of move on, because maybe you'll see some other example or something later on to help you fill in the blanks. And ultimately, if you never do figure that out for the rest of the book, you're just going to come back through and kind of hit those highlights, trouble spots anyway, so you can spend more time on it then.
And that totally makes sense too, if you think about it. How many times have you read something that you're like, oh, I understand that, and you go sit down on the keyboard and you go to type it, you're like, I don't remember anything I read. And I got to go back through the chapter and basically use it as a reference, right? Like, what did they do? Like, it seems so simple.
Yeah, so. I thought it was really interesting because it's total opposite of how I usually read tech books, which is like read chapter 1, I'm super pumped about it. I tell everyone they need to go buy it. I read chapter 2, I think I finished it, and then like I sort of remember chapter 3, and that's it. The rest might as well not even exist. The other 15 chapters.
Right.
I've definitely had some books like that. I mean, I try to go cover to cover. Kind of like what you're describing, Joe, but there are definitely some books. And in fact, there was a recent one where I got about halfway through it and I'm just like, okay, I'm done.
Yeah.
That's $30 gone. I can't finish it.
Sadly.
There's been a few like that for me too.
So I do have 2 books I've started reading because I'm an idiot, and I'm going to try and blast through. I'm going to try this technique. I've been highlighting already, so I'm going to pick one. I think I'll start with the React book since I'm further on. I'm just going to blast through it, highlight, and then we'll see how it goes.
So just skim through it the first time, highlight stuff of interest, and then go back through it a second time.
Yep. I think that's probably a good idea because I know the little React projects I've been playing with, I keep like redoing like the same map. I do some little stuff. I'm like, okay, cool. I like React, but none of them have routing yet because I haven't got to the routing chapter yet. I don't know how it works. And like, there's probably some stuff in there that's important.
So let me ask you this then. If you have a book on React, isn't it already out of date?
Yeah.
It was yesterday. Okay. It was published the day before.
I mean, it could have been published today and it was already out of date. By the time it went to the publisher.
Totally.
Yeah. And there's a ton of stuff in jQuery I've never even seen before. So this is just par for the course.
Cool.
All right, so moving along, wanted to take a quick second to ask you to please leave us a review. We got some great ones this time. We really appreciate it. And I was actually looking at the amount of reviews we have and really appreciate them because we do have a lot compared to like other podcasts, and it's really not fair, but I appreciate it. But if 1% of our listeners left a review, we would be sitting pretty friggin' pretty. We would be sitting good. I forget the expression. I'm tired, but it would be so huge, even if just 1%. So if you could be part of that 1%, if you could hook us up and help us out, it would be massive help for us, and would really appreciate it.
And then the other 99% of you, we need you to tell a friend.
Yeah, there we go. There we go. If you don't want to put your fingers on the keyboard, which, I get it though. I get why people don't do it because like me, I listen to podcasts while I'm driving, I listen to podcasts while I'm not in front of a computer, right? And so it's actually, I need to go do this. And so we really do appreciate it when you guys do it. But yeah, totally. If you're not going to do it or you're not going to remember, while you're listening, just take the AirPod, take the butt out of your ear and tell somebody, hey, dude, you should listen to this.
Be like, yo, you need to listen to this.
That's right. Hey, you absolutely have to listen.
Wow. That took a dark turn.
Yeah, that was dark. Sorry. No,
all right. Well, with that, let's take a moment to head into my favorite portion of the show. Survey says. All right. So back a couple episodes now, we asked, what's your social platform of choice? And your choices were Facebook for the old world.
The old gods.
Or Twitter. It's the best way to catch up on my kofefe. Or Snapchat, because a picture is worth 1,000 words. Or my favorite, Instagram, because a picture is worth 1,000 hashtags.
Yeah.
Or LinkedIn, it's all about keeping it profesh. Or Google Plus, I like the dust and cobwebs. And lastly, social, get off my lawn, kid. What, you want the government to know everything? All right.
That's awesome. Hey, a quick reminder, by the way, if you search for Joe Zack on LinkedIn, I will totally friend you as long as you're not a recruiter.
Yeah, same here. I'll even friend you if you are a recruiter. Yeah, I'm not going to draw lines.
And I'm weird about it.
Hey,
yeah.
Google Plus, though, did you guys hear it shutting down next year? I think August.
What did you say now?
Google Plus is shutting down next year, like in August, I think.
Yeah. I think it had a bug, and they're just like, not worth it. Not worth fixing. Security issue. Yeah.
That's going to require 20 hours. We're done.
Yeah.
But, it's not unlike Google, though, right?
No.
Hey, we created something. Oh, we don't like it.
Yeah. Gmail's going next, by the way. That's out of the
Don't even say that. Don't even.
Dude, you know how bad that would mess everybody up.
Yeah. Yeah, I hear great things about Flutter, but the part of me is like, I don't know. I remember Reader.
Yeah.
I remember.
Everybody's lost faith. All right. So who's going first this time? Is this Joe or me? I can't remember.
Alan, you go first. I think Joe went first last time. So you go first.
Man, I honestly, I have no clue on this one. Like, I think I'm, let's go with Facebook, and I'll say 17%.
Okay.
I'm going to say Twitter, because you can follow Elon Musk and he does crazy stuff.
You want to put a percentage on it?
Yeah, you got to put a number.
29%.
29?
Yep.
That's insane.
For Twitter. No, that's what it is. That's probably what it is.
Impressive. Okay. Well, then neither of you got the right one. Your percentages are both off, but between the two of you, one of you is more right than the other, and that's Joe.
Really?
Yeah.
So is it LinkedIn?
All right. So I gotta assume that people are messing with us though.
It's get off my lawn.
Because Google Plus was far and away the winner.
No.
And I'm like, that's not possible.
It could be your favorite and you still not use it.
That's true.
That's true. Maybe that's why it's your favorite.
Yeah.
Because nobody ever bothers me here. It's my nice, quiet place.
Wait, when you say by far, how much was this?
It had 42% of the vote.
Wow.
Dude.
So I'm pretty sure that people were like, having fun. They're like,
I think it's more likely that the people just like dust and cobwebs.
yes.
Yeah, dude,
nothing to do with Google.
If you actually go into Google Plus, it is a much nicer place to find information that you care about, but nobody uses it. Well,
if the information you care about is dust and cobwebs, then you're going to find out a lot about it.
True that.
Yeah. Second was surprisingly my people. Social.
Get off my
Get off my
lawn.
lawn, kid.
Yeah.
I thought that was surprising.
How much was that?
I mean, they all go downhill from there. Like that one was like 21% of the vote.
Okay, so we've hit 60 some odd percent in the two.
Just
So
right
that's
there. Wow.
Yeah.
Okay.
I mean, then Twitter for third and Facebook for fourth, and they were both close. Like, Twitter's 13%, Facebook's 15, or Facebook was 12%.
Where my snaps at?
That was last.
Wow. Okay.
Super surprising there. I actually thought that one would rank a little bit higher. I thought that one would be more popular, especially among a younger crowd.
But wait, isn't Snapchat all about getting rid of evidence, right? Like,
I think that's how it like started its thing, but like, that's why I was thinking it was like it'd be more popular among a younger generation because, that's not where your parents are, kind of thing.
Yeah, I will probably never be on that because I don't trust anybody that says that there's no history. That's
Like you can't take a screenshot.
Yeah, that's a lie.
Yeah, I mean, I don't believe in that, but yeah,
they started on a wrong premise. All right, so what we got for today's?
All right, so today's survey, or this episode survey, is what do you value most in a job? And your choices are pay. It's all about the Benjamins. Or tech stack. I need to remain interested. Or commute, or the lack thereof. I mean, I love listening to coding blocks and all, but a new set of tires every month is ridiculous. Or location, just like real estate. Or team. I need to be surrounded by people better than me so I can grow. Or industry. I want the type of problems I solve to matter to me. Or benefits. I like to take off for the summer. And lastly, work-life balance. I have a life outside of the office.
I'm really going to be interested in what these answers are.
I don't know.
Yeah, I have my strong opinion about what's going to be far and away the winner.
Oh, you want to predict?
And I don't want to taint the survey. No.
Okay.
I honestly, every one of these have been relevant to me at a different point in my life. So I honestly don't know how this one's going to pan out. So
we'll see.
Excellent.
All right. So we teased it a little bit, but now it's time to finally talk about primitives. And what I mean by primitives are the most basic types in a computer programming language that all other types are built on. They're kind of like the atoms of the universe, right? It doesn't get any smaller than that. And primitives refer to two things, and it gets a little gray and a little bit weird, just like anything else, because there's like the definition on Wikipedia, and then there's like what happens in the real world. And as I started reading about this, I started seeing just how much wacky, crazy stuff there was out in the real world, and it's like, I mean, this has got to be like a whole episode. So I just thought it was really cool, and I hope you guys think it is also cool. And those two types that I mentioned are the basic types, and those are things like the those elements that can't be broken down any smaller. This thing's like a Boolean, like it doesn't get any smaller than that, right? But then there's also built-in types, which are like things like the C# string, which is built in, and it has to be built in. We kind of discussed that a little bit, but it's not considered a primitive. There's also things like date time and enums and other stuff. And Lisp, the language Lisp has lists built in, but they aren't considered a primitive because they're composed of other various parts. And so Wikipedia has a list of the basic primitive types. We're going to deep dive these here in a second. And they have it listed as character, integer, floating point, fixed, and bool, and then there's a reference type for like things that like pointers.
So, we've hinted around about some of them, but the one that like kind of struck my fancy that I thought was kind of interesting to dig into that I never really thought about were floats and floating point.
Okay, yeah.
So for anyone who's not familiar, right, floats floating point is for decimal kind of numbers, like real numbers that have digits after the decimal point, right? Now, have you ever questioned why is it called a float?
Yeah, because we also have fixed points, which also have a decimal point, and there's obviously some sort of distinction there, but I've never been too clear on exactly on what that meant.
Alan?
Before recording or before setting up the notes for this, I don't think that I ever spent that much time digging into it, and then found some pretty interesting things while we were.
I know the point kind of moves, so it may be far to the left or far to the right, but I don't really know what that means, like under the covers, or like what the true significance is, other than it seems like it should be efficient.
Well, okay. So in a nutshell, though, that is the answer. Why it's called a float is that because the decimal point isn't in a fixed position. So you did mention fixed. So you have a fixed data type for decimal, in which case, let's say, okay, you have whatever the data structure is that you're going to use it, if in a fixed place, in a fixed decimal point, you're going to reserve automatically a portion of that space for what's to the left of the decimal and what's to the right of the decimal, right? In a floating point, you're not doing that. So, in doing some reading about this, though, there were some. I will have links to some really great articles. John Skeet had a couple really great articles written up, and it kind of made me think, like, my God, what does that man not know about C#? Because obviously, like, his articles were more coming from a C# point of view. But he linked to another one that wasn't. Well, actually, no, I take that back. It was from a .NET point of view. But regardless, though, the concepts and the theory behind it could apply to any kind of language except maybe JavaScript, because nothing does. But yeah, I mean, you think about, like, why do we need a floating point, right? Like, why is that even necessary? So we know how we can represent integers in a binary form, right? Like that we know how to do, right? So if I asked you, to represent the number 10 in binary, if we only used like 4, binary positions to do it, it would just be 1 0 1 0, right? And if I asked you to represent a 3, then you only need 2 positions, the rightmost positions to be both ones, right? So we can represent these integer-based numbers in binary easily, and we can even reason about it, right? Like, if you can think in your head, like, what the binary representation for the number 1 would be and what the binary representation for the number 3 would be, right? But if I asked you, okay, how would you take those same binary numbers, 1 and 3, and how would you represent 1 divided by 3 in binary? Right?
Oh, yeah, that's
I can't remember how to do that. Yeah,
that gets more complicated.
I think there's a mantissa or something.
Forget about binary. Like, just even how would we as humans write it out? We can't. We have to use symbols to write out the expression of what 1 divided by 3 equals. We would have to write out like 0.333, and then we would draw a line over the last 3 to represent that. Hey, that last one goes on forever, because we don't even have a way to represent that on paper, let alone how could we do it in binary form, right? And then you run into problems where it's like, okay, well, what if you did 1 divided by 3 plus 1 divided by 3, right?
Oh, yeah.
On paper, we might just end up with a result that is more like, 0.6667, because we'll just, round up that last digit and, consider that approximation to be good enough, right? Maybe we do that, or maybe we do the trick from the last time and we just do the line over the 6 again and say, like, hey, this is just going to repeat forever, right? But the point is like, then I'm pointing out there is like 2 things. Number 1 is we can't even represent this data on paper, let alone in a computer.
Yeah.
And we've already shown how, like, more like commonly we will just make an approximation and be like, that's good enough, that's acceptable, right? So how does this actually get stored in a binary form, right? So for a floating point number, you have there's three parts of it that are going to be important. There's the sign, there's the base, and which is, depending on what you're reading, might read it referred to as the mantissa or the significand, and then there's the exponent. So it'd be something like, for a binary floating point number, it would be something like -1 times 2 to the n, for example, right?
Okay.
The base, n being whatever the exponent is, in the -1 being the sign. In this case, you're trying to make it negative, right?
Yep.
So those are the three parts. So remember earlier when I said that, well, the data structure of how you store this in memory does matter? This is kind of what I was thinking of, was because I knew I was going to be bringing this up, where if you wanted to store you're storing this in memory, right? And let's say for a 32-bit float, you have these three parts to store. So 1 bit is reserved for the sign, 23 bits are reserved for the mantissa, and 8 bits for the exponent. And for the double, it's a little bit larger. Still 1 bit for the sign, 52-bit for the mantissa, and 11 bits for the exponent. But the point is that's a primitive in almost every language we've ever talked about, right? Like float is very common primitive, but it's that one data structure is made up of 3 very important pieces of information, right? And if you read these articles that I'll link to, like, oh my God, it gets even so much more complicated. Did you realize that there's a such thing as negative and positive zero?
Yes. Yeah. Only because of preparing for this episode.
Okay. Well, I mean, aside from preparing for this episode, because I never would have thought about it, never would have cared, but it turns out in like deep in the bowels of your computer, yeah, that's actually a thing. It actually does matter, but more often than not, it doesn't matter to anything. It's just, technically you can get an operation that would produce a result that would be -0, right?
Yeah. Does -0 equal +0?
If I remember correctly in the article, I tried to actually pull down, there was a code example that came with one of the articles, and I tried to find it, but it actually been pulled. But if I remember right, -0 did equal, I mean, it would certainly make sense. Everything would be broken if it didn't. It would have
I'm going to try it.
I don't have a C# compiler with me to double check that.
Isn't it .NET Fiddle?
JavaScript has it too, and -0 is equal to +0.
Wait! You're kidding me, right? You're not going to take JavaScript as any kind of source of truth for anything, are you?
It's truthy.
Yeah, truthy. Yeah, but so the interesting point there though is that it's because of that exponent that you're using, where you can, because that exponent could be can determine like which direction, where the decimal point is going, right? So that's what's making up the point. That's why it's called a float. Or though more technically in .NET, you would have system.single and system.double, and system.single is technically what a float represents, right?
Yep.
But if you were to consider what's the alternative to that, which is kind of what you hinted at, Joe, when you mentioned the fixed point number. So think back to currency from, like, if you remember any Visual Basic days, or in SQL Server, if you wanted to use the money and small money data types, right? It has a fixed decimal point, right? So in that type of data structure, you're kind of you're automatic, because you're automatically reserving space for those decimals. Then you're kind of capping what the range of that value can be.
Oh yeah.
Whereas with the float, because the decimal point can move, then it has more range as a result. of the number that it can represent.
Oh yeah, I remember in SQL you specify, you literally say how many to the left and how many to the right. It's like decimal 10-2. I'll give you 10 digits to the left and 2 to the right.
Yep.
Yeah, and then there was another thing that I kind of hinted at too, where you might have recognized or heard me say that a binary floating point number, which I'd never really given much thought to that either. But it turns out that there's decimal floating point numbers and there are binary floating point numbers. And at least in the .NET world, float and double are both binary floating point numbers, and the decimal is a decimal based floating point number.
Decimal based floating point number.
So remember when I was talking about like the example of how the floating point number is trying to represent a formula, right? -1 times 2 to the n was the example that I gave.
Yeah.
But change the 2 to a 10, for example. Like what if instead of a base 2, it was base 10?
Okay.
So but the way I couldn't quite find a clear definition on the float version, but the decimal version would be like take the -1, whatever your sign is. I'm using -1 just to emphasize the sign, but -1 times the mantissa divided by 10 to the exponent. And that was like one bit of question that is still a little unclear to me. Like, well, is it?
Well, that's how you get your floating decimal point, right? That's what that power would be. Yeah.
Well, but the point being that it's because I could have sworn that like what I was reading about the floats is that it wasn't like the mantissa times 2 to the n, but it was like the sign times the base times the exponent, right? Does that make sense?
I think so.
And specifically with the decimal, though, in this article that John Skeet had, he like specifically calls out that for the decimal type, it's the sign times the mantissa divided by 10 to the exponent. You know, and not exponent trying to decide like where you're placing your decimal point, right? But yeah, I mean, it was like so much more complicated than like just this one primitive, right, was way more complicated than I had ever considered it was, or actually is, because then there were cases of like, what do they call them? It was well, there were nans, but then there were signaling and quiet.
What?
Have you heard of these?
No.
Like you might see it as SNAN or QNAN. And it's not, honestly, they're both trying to represent not a numbers situations, but the difference between them are kind of, the quiet NAN, it says, is used to signify that the result of a mathematical operation is undefined, whereas the signaling NAN is used to signify an exception where the operation was invalid rather than just having an indeterminate outcome. Because like,
oh wow,
if one of the things that I was reading correctly was saying that like sometimes there were like one of these articles, I don't remember which, there was like errors that would be thrown, but like they were kind of trapped internally. Like you don't see them happen, but like internally it might get caught or something like that. If I was reading it correctly, like subnormal numbers, you know, like
yeah.
I mean, it was totally weird. Like how some of these things would represent, like, okay, so I told you like how you would represent a float, but then using that same data structure, how would you represent not a number? Or how do you represent positive infinity versus negative infinity and things like that? And then there were like all these weird cases where, and this is where like the negative zeros, negative versus positive zero might come into, play, where like one of the examples was like if you did an infinity divided by an infinity, maybe you might think that would be a 1, but it's not.
Oh.
It was like not a number is the result, I think.
Okay.
Yeah, I don't know how you could ever arrive at that.
How you could arrive at what?
At infinity, like you can't ever divide infinity by infinity because it's a never-ending thing. So there's no such thing, sort of.
Yeah, but
it's like real, but not real.
Yeah,
and then there's infinity times infinity.
But at the same time, we're also taught that, like, if you have the same thing above that, the same things below, then that's automatically a 1, right? But it's not. Right?
Not if it's
that's
0.
why I said, like, you might be tempted to think that it's a 1.
Right.
Yeah, I mean, like, floats are so much more interesting to me now than they ever were.
Yeah. We didn't really talk about what they were for, right? Like, Alan, you saw something interesting about discrete and continuous values.
Yeah. So while I was doing some digging into this, like one of the things that came up, and we'll have a Stack Exchange link to it. There was some really good answers because really, I think what I looked up is why would you use float or double versus a decimal or something?
It's always do fixed, right?
I mean, in your mind, like if you're thinking in terms of your dollars and cents, fixed makes a lot of sense because you're like, hey, if I have $20.35, I want $20.35 tomorrow and the next day and the next day. I don't want that to change, right? And floating point numbers don't give you that guarantee. They're not super precise like that. And that's kind of confusing to me just as a person, like, well, then why would I ever use the other one? It doesn't make any sense. And there were some really interesting breakdowns of why you would do this. So this article, like, I would read through all the answers because while some of them are probably more right than others, it's the perspective of the different programmers that really matter. So the ones that really jump out at you are people that work in physical type calculations. And so what it boiled down to is they said, why would you need floating point math? It's basically for continuous values. And that was really interesting, not more static values. And one of the examples somebody gave that was really interesting is if you were programming a video game and you're having to do the velocity of a bullet that got shot out of a gun, it is way faster to use floating point data types than it is for fixed. It doesn't matter that it's going to be off 1/1,000,000th or 1/10,000,000th of value because it's not going to impact the overall thing. But the math that can be operated on that thing is significantly faster than what can happen on a fixed decimal. And so in that case, it makes a lot more sense to use the floating points. There were other things like what Michael mentioned with the range. It's really weird. I forget, I've actually got on the notes here, one of them. So a decimal technically takes up more storage than a double, like quite a bit more storage than a double. But because it has fixed places for what it is on the, what'd you call it, the mantessa, basically the full, the integer, the integer value versus the decimal portion of it, it technically has a smaller range of whole values that it can go across because of that fixed decimal spot. So when you think about those things and you get into it, the use cases behind why you would use a floating point versus the fixed point, there's a lot of reason for it. Like they even said in financial modeling, right? You wouldn't use a fixed point because you're trying to predict things. And again, when you're trying to predict things, the accuracy to the 20th decimal place doesn't matter as much to you as the speed at which you're trying to calculate those things because it's a continuous calculation. When you are trying to balance your checkbook, you want that fixed. So you have to think of the use case. If you're doing physics or life-based or modeling or that type of stuff, then the floating point might be what you want to go towards. So really, really interesting answers from multiple different perspectives from people that do different types of programming that really kind of help bring to light when you would choose one over the other.
Well, I got something I want to expand on that, but first I want to clarify, like, you weren't suggesting that a decimal was fixed though, right?
Well, it's got a set number to the left and to the right.
Yeah, hold on.
You're talking about, but are you thinking about like in SQL Server? Because like if we're talking about like in a C#, right? It doesn't.
So
it is a floating type.
So here you go. Like, so there's actually an article that I linked to, and I'll just read the article because it'll make more sense than if I try and do it out of context. There's an interesting thing to point out when comparing double and decimal. The range of double is plus or minus 5 times 10 to the negative 324. So 5 with 324 decimal places of precision to 1.7 times 10 to the 308, while the range of decimal is negative 7.9 times 10 to the 28. So compare that to double, which is 5 times 10 to the negative 324. And then the opposite end of that is 7.9 times 10 to the 28. So it says, in other words, the range of double is several times larger than the range of decimal. And the reason for this is that they're used for quite different things. And this is, so double is a 64-bit floating point number. Decimal is a 128-bit floating point number with a higher precision and a smaller range. So it's the precision that you get because of where that decimal lives, I guess, is why you have a smaller range of numbers that it can actually fulfill, even though it's double the bits.
Is the point that I wanted to make, though. It is still floating.
Okay, I got you. Yeah.
Okay. But yeah, I mean, kind of going back to the cases, like when you would use it, though. I mean, like, yeah, I had my own kind of write up here just related to the floats. Is that kind of similar to how you were saying, like, depending on how you're going to use it, float might be just fine. I think John Skeet, he summed it up pretty nicely that, well, I'll put it in my own words first, is that like you said, if you're representing money, then you probably want something that's, that's precise, maybe a fixed decimal type would work best for you, or a precise type like the decimal instead of a float or a double. But, if you're doing anything if you're using this variable to represent anything from the real world, then like a measurement of a piece of wood, for example, then the float or a double might be good enough, because the likelihood that you're ever going to measure that thing, the same, like, yes, technically, like John Skeet made a point of like saying something along the lines of like, yeah, okay, technically you could measure something and say like that is 13 centimeters, but in the real world, if you're going to measure something, the likelihood of you measuring it exactly super precise, super precision, down to like 96 decimal places, right? Like that's probably not going to happen, right? So he says it is as if it's a man-made value, such as a currency, then you're probably better off with a decimal float point type. But for values from the natural world, like lengths and weights, then a binary is going to be better off. And the both of the articles I read had measurements that like one of them said that if you were to use decimals instead of floats as your default number of choice, right, that in terms of the calculations, decimals were an order of magnitude slower than floating points, as well as taking up twice the amount of storage in the case of a double versus a decimal, like you mentioned. But and then in John Skeet's write-up, he had he had some measurement that was like it was 40 times slower to use the decimal type than using the float. Now, I don't know how old this article is and what kind of hardware it was at the time. So maybe that still adds up. But there was another point too that I had read while researching this, which was like, well, why would you even bother with the float? Like if you did, for example, like one of the things I read, like if you had our love of var, right? So if you said var I equals 5, right? Then by default, it picks a 32-bit integer to represent that. but why?
Probably
Right?
because it's the easiest to store, right?
Well, it's actually based on the system. So if it's a 32-bit system, then the argument was, well, you could pick a smaller storage, type to store that, like a 16-bit integer, for example, could technically be enough to store it. But if the hardware itself is 32-bit, then it's going to be faster to use a 32-bit number. Same for the floating points, right? Like, floating point arithmetic is there's a lot of optimizations that are already happening for that.
Hey, so check this out. Going back to the floating point, this was interesting also in that one article that I read the snippet from earlier. This was really cool. So what they did, and it's pretty simple math, so I don't think it'll be too confusing to talk about. They took the value 10, and then they multiplied it by 0.1, a double value of 0.1. And then what they did is so that's 10 times 0.1 is 1, right? Or is that what 10 times 0.1? They did something weird here in the thing, but at any rate, so it should come to 0.1, and then you're going to add 0.1 10 times, right? That's essentially what you've got. Oh, that's what they did. Okay, so 0.1, they multiplied it by, you'd expect to get 1, right? 0.1 times 10 is 1. But then they took the 0.1 value that they had assigned to X, and they said, add it together 10 times. And what would you expect to get? You'd expect to get 1 again, right? 0.1 plus 0.1 10 times should give you 1. Here's the thing, and this is what's interesting. It doesn't come out to that. When they do that, at least in C#, they got 0.9999999 something 89, however many number of nines. And what they said was the reason is this, and I think Outlaw, you had either mentioned this or alluded to it just a little while ago. Basically, what they said, in most systems, a number like 0.1 cannot be accurately represented using binary.
Mm-hmm.
So there's going to be some form of arithmetic precision error when you're doing this. And so when you take that value and you start adding it up multiple times, instead of getting that nice, neat multiplication that it can just shift those bits and make it happen really easy, now it's trying to add these imprecisely stored numbers. And so you have this little bit that's off at the very end of it. So that's your precision error. And it's all because of how that data is stored in binary. Now, it's way faster. So if you can live with that, I mean, God, I don't even know what place this is. It looks like it's probably in the 15th place that it's off by, whatever that is, one of those. So if you can take that hit, and like he said, if you're modeling something in the real world that's not probably money that you need to make sure stays the same, then you can probably take this hit and it's not going to hurt anything.
So check this out. I just ran a little test. 3.2 is one of those numbers that you can't really represent either one. So if you do in C# 3.2f, which makes it a float number, equals equal 3.2, which is a decimal number, then you get false. So 3.2f is not equal to 3.2. And if we actually print out these numbers, you'll see that the floating point ends up being 3.205. And the decimal ends up being 3.202. It's kind of funny that it's ends up being a big difference. But if you are trying to compare two numbers, so like even if you look and it looks like 3.2 should equal 3.2, it may not because of those underlying primitives.
Yeah, the equality thing is probably a big deal, right? Like that's something you'll have to pay attention to if you go to use these things, is because there's going to be some margin of error that you're going to have to account for. So just like you said, that it's not going to equal the other one. And you're going to look at it and be like, well, why? I know that's the same, but no, you didn't. The storage behind the scenes is what matters, and so they don't equal out at the end. So yeah, it's pretty cool.
There, even in the article that I had, they had a similar example where it was like, if you did something like that and you would expect to give like a 10% discount, but because of these kind of rounding errors, whatnot, you actually end up giving an 11% discount when you meant to give a 10, because the way it ends up working out. Yeah, I mean, after digging into floats, it's definitely my new favorite data structure. So I'm going to use it for everything. See that in an upcoming pull request. But I mean, even in what you were describing, Alan, there was you have to take a moment to even talk about like precision and accuracy and make sure that like, okay, let's lay some groundwork here and make sure that we're all on the same page, right?
Right.
And so precision refers to the amount of information used to represent the number.
So 4 decimal places, right?
Whatever, yeah. Like if you're using 32 bits to represent that number, that's your precision, right? But your accuracy indicates how close to a value it is to its true value, right? So this is where the floats, that their accuracy isn't like exact, right? They're close, they're approximations. And I think it was still in the John Skeet article. It might have been in the other one, because there were like 3 different articles that I like really used as the reference when I was learning about this, deep dive on floats of all things. But there's this great idea here that was like, hey, okay, we're all familiar with pi, right? The number, not the food. Or
we're familiar with both.
Yeah.
Let's be honest. We're not
one more than the other.
Yeah.
But yeah, so if we were to represent pi as an approximate value using just the number 3, right? It's only accurate to 1 decimal place, right? No matter what precision the variable is that's actually being used to store it, right? In that case, it's still just the 1 position. That's all that it's accurate to. Does that make sense? And I thought that's a really good way to try to understand the difference between precision versus accuracy.
Hey,
like so another example was like if you had 0.3 versus 0.30, right? And you're trying to say like, oh, well, one's more precise and one's more accurate, right? Like the 0.30 you might say is more precise because it uses more digits to represent it. But, in terms of its accuracy, they're both the same accuracy.
Yep, totally. So going back, in C#, -0 does equal 0. That came back true.
Yeah, I kind of assumed it would. I just didn't have a compiler handy.
Yep. And then the other thing, so going back to using the floats, the doubles, those, one thing to know is a simple operation like, just adding 2 together or multiplying 2 together, you're probably not going to get results that are that far off. It's as you continually compute things that your margin of error is going to grow, because all those non-precise multiplications or computations that you're doing start to compound. And so that's where you'll actually start noticing, because I think I ran into this years ago where I was using them. And, in simple things, you never noticed it, right? But as soon as you did something 20 times in a row, you're like, wait a second, why is that number, why did you do that wrong? So you need to be aware of that. It may not crop up until you've done something multiple times before you start realizing what's actually going on.
I could have sworn that it was in these same articles, but there was definitely, it must have been something else I was reading about rounding too, and like all of the different forms of rounding that happen, because that could like play into your situation, like as you're running through the operations there, if it's on a round down to 0 versus a round up versus like, what was the bankers rounding?
Even rounding, yeah, the bankers rounding.
Oh, even rounding was what they called, yeah.
Yeah. So that one was really interesting. This actually came up on our Slack channel months ago. It might have even been a year ago now, but it was a really good thing. I want to say it was in Dev Talk. Have no idea who was involved at the time, but somebody was like, why are my numbers not rounding consistently. So you'd get 1.5 and it would go to 2, but then you'd have 2.5 and it would also go to 2. And he's like, why is that? And it's because there's this thing that Outlaw just referred to as banker's rounding. It is also called even rounding. Basically, if you're halfway in between two whole numbers, 1 and 2, it's going to round to the even number every time. So if you're between 1 and 2 at 1.5, it's going to 2. If you're at 2.5, it's going to 2. If you're at 3.5, it's going to 4. And Outlaw even mentioned when we were talking about this the other day, we're not just talking about whole numbers. It could be something to a decimal place, right? But the gist of it is it's going to round the next number up or down to the closest even number. So, yeah, if you're not aware that math.round in C# does that, then you're going to be scratching your head going, what in the world? And that's the crazy part is, and we're going to get into this in a minute with some other things, but every programming language implements things differently based on what they thought at the time was the best way to do it, right? So, pretty cool stuff to know about, and the kind of stuff that you'll spend hours going, this is wrong. Why is it wrong? Why is my programming language wrong? Right?
That's ridiculous.
It's pretty cool, though.
All right, so now let's take a look at a couple languages, and we'll take a look at the kind of primitives and some of the built-in stuff that they've got in there. But first, I wanted to kind of bring up something that you hear a lot of people talk about, and it's the notion that everything is an object in languages like C# or Python or Ruby. And that's true. You can do even like a number 144 dot to string, and it's an object, and you can call the methods on it. So it kind of struck me as kind of odd to think of these things being primitives when they're an object. If even a number has ultimately a class behind it, then how primitive is it really?
Well, you're talking about like in the case of C# where everything extends system.object, right? Everything.
Yeah. Everything. It's either, even from there, it's like value or reference type. So system.object isn't, when you get down to int or something, it's still like 3 levels deep. It's kind of crazy.
Yep. So you said, isn't everything an object? But then you said the answer is?
Not quite. Yeah, and things get really weird depending on what the language that you're actually looking at. And so I actually made a little spreadsheet here. And I'm going to flip over to now where I took a look at those primitives that were defined in Wikipedia, and I tried to match them up with the actual programming languages to kind of see how things fit with like the conceptual model of how these things should fit. And what I found is that things are really different and really weird. Every language had their own quirks. I took a look at 3: C#, Python, and JavaScript. And each language just had some interesting details that I thought were, like pretty different at a fundamental level. And these are things like, I bounce between C# and JavaScript all day, and I never really thought about it because they're kind of the edge cases. And so for the most part, 2 + 2 is going to equal 4. And so you don't really hit this stuff too often. But when you look down kind of underneath the cover, so it's pretty complicated. And so I guess if you're doing like really math heavy stuff or doing some weird infinity dividing type stuff, like maybe you hit this stuff more than I do. But I just thought it was really cool to kind of peek behind the curtains here and see how it all works.
So I'm going to interject some thoughts on Java and some C stuff in some places because there were some interesting findings on those as well.
Yeah.
But yeah, let's
take a look. Yeah, so the first type that Wikipedia listed was the character type. And C# has system.car. That's no problem there. Underneath the covers, it's actually storing it as a number. It's basically Unicode, which goes from like 0000 to FFFF, whatever numbers those are in hex. So that's ultimately the biggest numbers that they can kind of fit in there. And what I thought was particularly interesting was that if you go and you look at JavaScript, they don't have a character primitive. The smallest thing they have is a string. And like we kind of said earlier with C#, like we said that strings weren't primitive. So how can it be that JavaScript has a primitive, the smallest building block of string, and C# has something different, a car, and its string isn't even considered primitive?
I'm sorry, did you say car?
Car character, dang it. And Python is the same way. There's no such thing as a character type in Python. It's just string. And it's a string of one character is just a string of one character. But in C#, a string is actually a collection of characters. And got some other kind of interesting notes here about C#. And like strings come up a little bit. I don't want to go too deep into it. Really, you could do a whole up. Hey, say what?
Well, I was curious, like, I mean, you're teasing me here with this question. And I was like, well, okay, so what was the answer? Like, how does JavaScript get around that?
It doesn't. It just doesn't.
It's actually the primitive. Yeah, so there's no underlying to it other than the fact that it's string. Now, in fairness, here's the thing to know about JavaScript as we talk about all this. The implementations of it can be totally different based off whether they're using the V8 engine from Google or whether they're using, I forget what some of the other ones were from Microsoft and other engines. The underlying implementation can be doing whatever the heck it wants, but when it all boils down to the language itself, string is actually the primitive of the language. So, yeah.
Yeah, it's wacky. And JavaScript does support Unicode too. And actually, there's a funny glitch. I think you guys have both seen it probably on Stack Overflow or stuff. It comes up every once in a while on Reddit or wherever, where JavaScript Unicode has a flaw in it, a glitch, where it starts kind of writing things sideways. You know what I'm talking about? Where they were saying a thing where like the text starts, and as you keep reading, it keeps descending into chaos and getting weird, and like text starts going sideways. And you know the thing I'm talking about?
No.
All right, I'm gonna find this.
I know what you're talking about, but I can't remember. I was trying to like remember what to search for so I could put the link in.
Like JavaScript Unicode glitch is probably a good thing to look for. Yep. So I got a link here.
Has a Unicode problem from 2013.
Yep. And so if you scroll down, hopefully there's a picture on this article. Yep. So if you get far down enough, it just looks wacky. I don't even know how to read it. But there was this famous Stack Overflow question where somebody said something about Unicode and JavaScript, and the person started explaining why it was a problem. And as you start reading, it starts getting weirder and weirder, and then the things start turning sideways and looking like not even what am I look at? And the whole thing kind of explodes. So we'll have a link to that. I'm going to find that link while someone else is talking up here in a minute. But yeah, I just thought that was really cool. And there's some other interesting properties about strings and characters that I wanted to mention real quick. Like, for instance, in JavaScript, strings are immutable, which is also what C# does with their strings. And what I mean by that, in C# at least, is that every time you make an addition to a string, like even if you lowercase it, uppercase it, concatenate a letter, it ends up creating a whole new string at a different location in memory. The original string never gets modified, and that's why they always tell you to use those string builders, because with a string builder, it's more efficient, and so every little change to that string doesn't end up reallocating the whole size of the string. Again, it just allocates a bunch of memory, kind of like an array, and then we'll kind of append to that buffer. And then when it's time to actually generate the string, it'll just do it once rather than doing it with every little change there. Now, JavaScript doesn't have a string builder. So you're just kind of out of luck there, trying not to build too many strings there. But they're immutable in the same way. So every time you do it, it reallocates. And in C#, there's also another kind of weird quirk here, where if strings are a reference type, right? So they are stored on the heap, and you get a pointer over to them. But they behave a lot like a value type. So if I say, string name equals Joe, string name 2 equals Joe, and I check to see if name 1 equals name 2, it's going to tell me true. But that's not how reference types normally work. When you do equals equals on two reference types, like two objects, it doesn't compare the properties. What it does is it basically looks at the actual kind of pointer to that object and says, hey, is this the same object? If it is, then go ahead and return it. Return true, otherwise it's false. Strings don't work like that, because when you create the same string, it actually points to the same spot in memory, which is really funky to me. A good example here of kind of example is like the empty string. There's only one empty string in all of C# memory. So when you create a new string and you set it to empty string, it's pointing to that memory location. If you create a second string, set it to empty string, just quote, it's pointing to that same spot in memory. So now if we say, does string name1 equal name2, they're both pointing to the same spot in memory. The answer is yes.
That's really cool. I didn't know that.
Because you're referring to an optimization that it's making.
Right.
Rather than having like a bunch of memory stored. I mean, let's not even talk about the comparison optimization benefits you're getting by only comparing pointer addresses, but just from like a memory space. If I had a variable that stored all of the text of the book War and Peace, and then I create a second variable, and I also want to store all of the text to War and Peace, the exact same text in it, as an optimization, it'll just both point to the same location, and not until I need to change one, then it's like, okay, fine, we got to get new memory for this other variable.
Wait, I don't know if that. So you're saying two different variables that have the entire story? They wouldn't point to the same thing for that, would they?
If you let's make it smaller. I make a string one.
Just
let's say,
the word
string S1 equals hello world. String S2 equals hello world. They both point to the same block of memory.
They're two different pointers to the same location.
Wait. We're talking even for the values of the string. So
yeah, strings are going to blow your mind here, man. They're everything that you've learned about this, about like the way pointers work. You're thinking like, well, no, that's not how it works. But for strings, it does as a matter of optimization.
So is it hashing it and throwing it into a particular spot on the heap or something so that it knows to do it? Because it's not going to try and compare it and find where to put it, right?
I don't know how that part works. I wouldn't be surprised if there was some sort of hash. I mean, like C#, all objects do have a get hash code type thing. So it probably does do some sort of thing like that. So it knows exactly when to do it. And so it doesn't double up.
It's not until you decide to change it. That's when it's like, okay, fine.
I need to allocate more memory.
Basically, imagine that like the references to that block of memory, gets decremented. So now it's just the one reference, and the second variable gets some new block of memory,
right? With its own pointer to that place because it's the only one that lives
to whatever
there.
the new string, to whatever the new string is. Now you also get so that's a memory optimization that you gained from it, but then you also get the comparison operation optimization that Joe was referring to, because now when you want to do an equality check, I don't have to go character by character through each string.
I just look at the pointer.
Instead, I take, instead of what could be like an O of n operation, I take it to an O of 1 by only comparing the memory address.
I didn't know that. That's pretty awesome.
That's pretty wacky. I don't know if Java does that. I think it doesn't, because I seem to recall like working in Java and you'd have to do like the dot equals function instead of just the equal signs. And that's because when you did the equal sign, it would do that reference comparison and say, nope, this is not the same object, rather than comparing like by the value, which is what I expect.
So did either one of you guys know this before we were doing these notes?
I knew the string. I knew this about the string. Yeah, I learned a lot about floats that I didn't know, but the string optimization I did know.
That's awesome. Cool.
Yeah, this is one of those things that I read about in CLR via C#, and I kind of read it and I'm like, I don't believe it, but I'm just going to kind of sit on it. And every couple of years I go back and I'm like, did I make that up or is that real? And it's real. I checked it again recently.
That's awesome.
Yeah, I'll include this. Actually came up in like a Stack Overflow, so I'll include a link. And I think you're right, Joe, because I also read that book CLR via C#, and that might be the same place that I learned of it too.
And the Java thing makes sense because exactly what you said, the double equals is checking reference versus the value dot equals.
Yeah, so you could debate as to which one's right. That's a weird thing. There's actually a lot of other cool stuff going on with strings, at least in C#. Like there's secure strings, which are basically designed to not stick around in memory. So if you have a password or something, you can throw it into a secure string, and it's disposable. So it's like meant to be kicked out of memory as soon as possible in case there's like a core dump or something. There's also string interpolation in C#, which is actually done in a neat way, where there's a class that inherits from string, and it's got actually some special properties. So that even though it looks just kind of like a string with a funky character in front of it, it actually is a little bit different. It just happens to work exactly like a string everywhere because it inherits from string. Strings are just really freaking cool if you take a deep look at them in C#.
Well, I mean, they're not as cool as floats, but yeah.
Yeah.
I don't know. They might be cooler.
Yeah. See, man, screw data structures. This is where it's at, man. Primitives are hot.
Well, I mean, like I was obviously joking about the float part, but it did make me think though, like while reading about the floats, like, yeah, you're right. Trying to express numbers in binary sucks.
Right?
But you know what we can do? We could represent any number we wanted to as a string.
Yep. And guess what JavaScript can do?
Yeah. It can use strings.
Okay, but I mean, I was actually thinking back to like the three of us I know have been in this situation where there was the search engine that we were using at the time, we couldn't store fractional numbers, right? But we could store strings, for example. I don't think it stored numbers at all. Now that I think about it,
no, it did.
we could take the fractional numbers, multiply them to be whole numbers. Yeah, maybe that's what it was. It was only integer based,
right?
But at any rate, like, yeah, that's kind of what I was thinking. I had memories of that situation where we had to represent decimal based numbers as whole numbers, and then just we knew that we were going to have to like some exponent in order to like move the decimal point. So memories of that, plus hey, you could just store anything as a string while going through the whole float thing.
Yep.
Yeah, and you actually reminded me of a good point. Just for fun, I was searching around at different libraries in C#, and I noticed that there was one that added kind of a library for I forget what it was now. It was a long 64, where they kind of added an approximation of a data type, and they basically did it by keeping two long numbers. The first was to the left of the decimal point, and the second was to the right. And then if you wanted to add or anything, the library would take care of like adding things appropriately and carrying between the two numbers. So it's just kind of a funny way of representing a large number, and they'll let you do some math on it. And it had a lot of tests, but there was a note in the README that said like, no, we're still kind of iffy on those square roots. So math is hard.
Well, that's one of the things that was an interesting takeaway from Java is Outlaw mentioned earlier, if you just said int I equal 5, it's going to make it a 32-bit integer, right? Well, with the 64-bit architectures now, if you assign something, you can go up to a 64-bit number, right? The interesting thing was in Java, they didn't allow you to for, I want to say, man, where did I put the note? I can't remember where I had it. I don't remember if it was the double or which one it was, but they don't have a 64-bit representation. It caps out at whatever the 32-bit number is, and they don't have an implementation for the 64-bit, whereas in C# they do. And this isn't saying one's better than the other. It's just that they just never implemented it. And there's workarounds that people have done similar to what you're talking about, where you sort of concatenate two together, or you come up with other things to do. There's even people that have written specifications and recommendations to the Java language to say, hey, this is how you would do it. And they've just never implemented it.
Yeah, and actually, you bring up a great segue. So for integers in C#, this is the next data type, integer. I'm counting 12 different types of integer in C#, and they range from S-byte, which is 8-bit, all the way up to longs, which are is that 64 bits? Is that right?
I don't know that that's 64.
It's a lot. It's a whole lot of numbers. But the 12 different types are kind of weird because they're split up differently. So there's like things like byte and short and int, which are 8-bit, 16-bit, and 32-bit. But there's also things like unsigned short and unsigned int, which give you more range in the positive direction by not letting you have negatives.
Right, you get that 1 bit back that you're not having to assign to a sign.
Yep, and that 1 bit back, every bit you add is it's a lot more.
It's exponential, right? Like, so yeah, it gets much bigger.
It's literally exponential.
Yeah,
it is 64-bit. I went back and double checked.
Okay, the long is cool.
Yeah.
Okay.
So the int that you have there would be the 32-bit integer. I guess the short that you have there would be like an int 62. I'm sorry, 62.
And
Making
16.
fives here. 32-bit is what you have represented as short.
Yeah, I do think it's interesting that there is not a bit. So the smallest you can go in C# is just 8.
Yeah, the byte.
Yeah, I've never needed 1 bit. I would just use a Boolean, right?
Well, that's what I was going to say. That's really what the bool is. So.
Yep. One thing I wanted to mention here, well, 2 things kind of. One is the kind of the point you're talking about, Alan. Long is 64 bits, but we know that C# and the CLR, it doesn't have to run on a 64-bit machine. So what happens if you write a program that uses a long variable and you try to run that thing on a 32-bit system?
I don't know.
It still works. And that's because the CLR is designed such that it will basically store that thing in 2 memory locations, and whatever I guess the CLR, maybe the CLS, I get the common language runtime versus the common language specification, I guess it would be the runtime, is responsible for saying, hey, go grab these 2 memory locations and then let's do the math in 2 chunks and add it together and store it in the same spot. And that's how you can have data types that span something bigger than the processor can handle.
That's cool. Hey, I actually made a note on this one. A long goes up to 9 quintillion.
That's crazy.
Yeah, that's a lot. So both positive and negative for the whole range, right? That's for a signed long or just a long. The unsigned long, I forget what it goes to, but it's ridiculous.
And we mentioned that C# has a -0 and +0. Unless you're in unsigned int or one of the other unsigned ones, in which case you're just going to have 1 0. One other thing I wanted to mention is the unchecked keyword, which is the thing I don't really think about too often. But in C#, by default, it's going to check to see if you're going to get an overflow error. So if you try to add something in the quintillions with something else in the quintillions, then it's going to stop that before it actually runs it. It's going to say, I can't do this because it's going to overflow the memory location, so I don't want to give you essentially a wrong result as things kind of wrap over. So I'm not going to run this. But if you want to be risky, you want to be Evel Knievel, you can actually set unchecked above that region, and then the compiler isn't, or not the, I guess it'd be the just-in-time compiler is not going to say, it's not going to check that ahead of time. It's just going to do the math, and it's going to trust that that it's not going to overflow. So this is something that you would do for basically for efficiency. That this needs to run fast, and that the numbers that you are adding are not going to overflow. So I thought it was kind of interesting. That's one of those things. I kind of feel like, does that ever come up ever?
Well, I wonder.
Not for me.
Use cases of it though. I've got in my mind what I think the common use cases might be.
It's really fast.
Huh?
Something like really fast graphic stuff.
Well, that maybe that's it. I was thinking around encryption related things or cryptography, where you're using really large numbers and you can't do normal operations like a square, for example, because it's already so large. So there's other shortcuts, there's other tricks, math tricks to do for operations like that on large numbers.
Mm-hmm.
So that you can get around overflows, for example. Maybe that's where that comes into play.
Is there ever a time where you're just okay with the overflow?
Is there ever a time? I mean, yeah, if you're trying to hack something, then you definitely.
Yeah, I was going to say.
Yeah, I normally think of that string overflows as being the bad one. You can kind of write something into a memory location, and for some reason, I don't know if this is true or not, but I had it in my mind that number overflows didn't matter. You would just get the wrong number because it would kind of wrap. It wouldn't actually write into memory that it wouldn't, that it shouldn't be able to. I don't know if that's true or not though. So I don't know if unchecked is a security concern or not. But you should probably not do it unless for some reason you really need it.
Agreed.
Now, looking over at JavaScript, all we have is a number. It's called number. And if we look ahead a little bit here at the fixed and floating points for JavaScript, no, there's just number. It goes from -2 to the 53 to the positive 53 power. There is a -1. negative 0, a positive 0. There's also not a number, which you'll notice is of the type number. So not a number is a number.
Well, one thing to note though, while there are only numbers, they have libraries built in to convert things to a float or to an integer or these other things. So they have utility methods to get to a particular type that you want. And by the way, if you ever do something like parse int or parse float, I can't remember which one, you better make sure you put the base 10 in there. Otherwise, you get some really bad results.
Yeah, that's weird.
But yeah, so while they only have number, they have methods to sort of force it into something that you would use in a more strongly typed language.
Yeah, so that was pretty cool.
I would say that you said that not a number is a number, but I think maybe the more accurate or way to say that, or at least maybe the more understandable way to say that, is a number is used to represent not a number. Like kind of going back to like what I was saying with the float conversation about how, depending on like even within that data structure, it could represent things like negative infinity, positive infinity, not a number.
So I think what he's saying is if you type in type of NaN, you get number.
Yep, that is the data type of not a number. The N, capital N, lowercase a, capital N is number.
Yeah, I'm with you. It was just so comical though to say that like not a number is a number.
Is a number. Yeah, it's a paradox.
Yep. So the type of not a number is equal to the type of 0.
Right.
Or 11.
Doesn't make any sense.
Yeah, so it's kind of funny. And it's actually really funny when you look at this stuff and you think about like kind of the truthy stuff that people talk about in JavaScript. A lot of it kind of boils down to this type of thing where, a lot of times you will see someone do that example where they type of NaN is equal to type of 11. Python does have int and long. So, very kind of similar. I didn't look to see if they had an infinity. Oh, they do. INF. That's pretty cool, but you actually have to use it in a function. So it's like float of INF. Pretty neat. Moving on to fixed points. So C# has decimal, and that's just it, right? Just the one. And they've got a pretty big range here. I can't really say those numbers.
It's pretty big.
Yeah. And it goes up to 96 bits. And this is another one of those cases where we don't have 96-bit computers, but that's how much it takes for each one that you allocate. And it's actually got it separated into multiple, in this case, up to 3 memory locations. And it's going to kind of combine those in order to get your actual number out of it. And so for fixed types, I have question marks here. It looks like I meant to look that up. Does Python have fixed point type?
It has integers and float. But
does it have no fixed point
types?
All right, that's it. Oh, that's right. I remember this now. There's a library that is we call them decimal library that people use for doing fixed point type math, but it's just kind of like we talked about where it stores that stuff like one number for the left and one number to the right. And it's responsible for taking care of making sure things add correctly.
So the answer is it's not a primitive. It's a library that you can go get for the language.
It's not a primitive.
Okay.
So I'm going to put no there in the spreadsheet.
All right.
All right, now we're on the floats, and that's we talked about that quite a bit already. C# has single and double. So when you see the word float, it's actually an alias for the single data type. That's kind of weird. It's a weird name for it. It's not what I would expect.
Yeah, I mean, it makes more sense it doesn't make sense out of context unless you talk about double, because then you say, well, a double is double the space of the single, and you're like, okay, I guess I get it. So maybe another way to say it is like, we started with the 32-bit and then went to double, but that's not true either, right? Because then you're ignoring a lot of computing history where you're like, hey, wait, 8-bit was a thing for quite a long time, and then 16-bit, like we did. You're back in my day, you know.
Yeah.
So it's like, yeah, it's kind of like at some point, like Microsoft decided to, revisionist history is what you could call it. They're just like, you know what, forget it. We only ever had float. It was a 32-bit thing. That's the single, and then we decided to go crazy and double that. Like, woohoo!
I would love for you to do that again.
Yeah.
You would what?
Yeah, do the voice.
I do. Yeah.
Oh, you want to hear it again?
Yeah, I do.
Oh, no way. Now you made it awkward. Now I'm over here blushing. No.
It's so good, man.
Yeah, sneak it in. So I think maybe they just started with float and they're like a single double, and then they got to answer like, oh crap, single and double are taken, so let's do short and long. Sure.
Yeah. Yeah, we forget that computers weren't always as strong as they are now.
Yeah. Now
maybe it's not even. Maybe we're giving them like way too much credit. Like somebody just like walked in and man, that's a really long number. That's what we'll call it.
Yeah. Hey, gaming's hard, man. Gaming's hard.
It really is. Like you could just imagine like someone, like the janitor walks in or something. Well, that's a really long number you got written on the board there.
That's it.
Yeah.
That's the genius.
Yeah. I mean, we've been working with these systems for, I don't know, 50 years, 100 years, thousands of years. And float is the best we could come up with to describe this big, complex, thing that we talked about.
But now I understand that one. That one makes sense to me. Float makes sense to me now.
Yeah, I mean, it's not a good word. Like, if someone said, "Hey, what about the word float for anything now?" I would say no.
Well, root beer?
It's just I like words with strength.
Root beer float. That one's okay.
Now, Boolean is okay. Boolean's a good term.
Boolean's got a strong name to it. Yeah,
it's got strength.
It does.
Yeah, and actually, JavaScript and Python, they got nothing to say about it. All right, you can have Boolean.
Yeah, everybody followed suit there.
Yep, nothing weird there. Now we're about to get weird again. So we have the reference types, and in C#, we've got int pointers and uint pointers, and apparently uint pointer is not a CLS thing, so it's not common across all the different languages. So maybe F# has it, maybe it doesn't, maybe VB has it, maybe it doesn't. C# has it, but you shouldn't use it because anything you do with C#, it's not going to be able to interop with those other languages. So you should stay away from it, unless for some reason you need it. Now, in these other languages, so JavaScript has object, but it's not considered a primitive. So that kind of got me thinking. It's like, well, what the heck? Like, how is it not a primitive? Like, isn't this the basic building block? Can I do it myself? And so I kind of did some reading up on it, and basically Mozilla is kind of the authority here. So all blogs kind of lead back to Mozilla when it comes to the types, and they say that the object refers to a data structure containing data and instructions, but they do not consider it a primitive type unless it's one of the other ones that we've mentioned, and one of a couple others that we've got coming up that are unique to JavaScript. So, I don't really know what to say about that. It's kind of interesting to me that JavaScript has an object which is not a primitive, and C# has an object that is not a primitive. However, it's got primitives that are objects.
Yeah.
So int is an object. Int is a primitive. Object is not a primitive.
Yeah. Yeah, I got nothing there.
Yeah, and the only thing I can think to say there is that, like, Wikipedia, this is a general concept. So this is kind of like a, like a flickering shadows on the cave wall kind of thing, where like, this is the concept, this is what we're going for. But in the real world, things just don't quite shake out that cleanly.
Well, I get it why object is not a primitive, though, because it's just what you said. Primitives are the most basic building blocks of what can be in things, right? You can't break them down any further. Object, you can't. Now, the C# thing, I got nothing. I don't.
Yeah, and Boolean is an object. Like true is the value true is an object.
Yeah, so I mean, it's hard to say anything about that, but I get why object is not a primitive in JavaScript. I mean, really, so what we've talked about so far in JavaScript, really the only three that we have are string, number, and Boolean, right?
Yep.
Okay,
So far.
so far.
Yep.
You said that. Did you say that int was an object though?
Yes.
Yeah, it extends the object class. That's what we were getting at. Why it's so weird to even talk about the fact that system.object is not a primitive, but yet the primitives extend it. So you've got things that extend system.object that are primitives, but yet object itself is not a primitive. And so it's just kind of a weird way to think about it. I mean, they probably just got some weird rules in their compiler to make that so, but yeah.
Yeah, so in C# you could do like the number 123.2 string, and it's going to work.
But I thought it went back to struct.
Even if it did, that would still everything in C# extends system.object.
Yeah, including struct, right?
Oh, right. Okay, I see the inheritance tree now. I'm looking at it now.
Yeah, struct is a value type, which is an object. So struct is even 3 levels deep.
Yeah.
It goes object value type int 32.
Yeah, it's just weird. And so value type is how they force it to where it's the primitive, but yeah, it's all mind-numbing.
I should go back and listen to our boxing and unboxing episode.
Yeah, especially that part about like value types and reference types and how they kind of end up, and there's some interesting things about how they're assigned, and yeah. But I forgot all that stuff already. That was 5 years ago. Come on. So Python.
Show notes.
Python also has objects, not primitives, though. Now, the weird ones.
Wait, now the weird ones?
Now the weird ones. And I'm going to go a little out of order here. The notes. So undefined in JavaScript is a type. If you just do var x, enter, then you've created a variable x of type undefined.
I think I remember reading something about this.
Right.
We were just talking about like the differences between the null type and the undefined type, and that they had like specifically different meanings.
Yep.
Undefined meant that the type hadn't been decided, but null meant that the value hadn't been decided.
Yep.
Something like that.
That's exactly it.
Oh, good. I solved that interview question.
Oh yeah, crap. Man, I think I did it wrong. I think I totally just said it wrong. I screwed everything up. So when I did var x, it's null, right? We're gonna have to pop this open. Var x. So I can okay, var x is undefined. Okay, I was right. So if I say if x equals 5, what happens?
X will be a number.
Then it would have to. Then you're assigning a type to it.
Okay, so that's why it doesn't error out, right? So now if I look at my value x, oh, that's really weird. So I say var x, it's undefined. And then if I say if x equals to 5, it coerces that x into a different type. And now if I print that x out, and it shows me this weird apply call, that's really weird JavaScript stuff. But it's no longer undefined is my point. So a type changed just by doing an inequality comparison.
Yeah, so like if you do var ASDF, you'll get undefined, right? Which is what we were saying.
Yep.
Yeah, but I didn't realize though that just by doing the equality comparison in JavaScript, it would change the type of an undefined type.
Yeah. So what if we do var x and so if
Am I hearing you right? That's what happened?
No, it did not. So I did ASDF. I defined it using var, and then I did ASDF equal 5, and I still got undefined for ASDF.
That's not what I'm getting.
I'm in Firefox.
Did you do an if, or did you just do the equal?
I just did equal. So you're saying
do it if
ASDF equal 5. Now I'm going to do SDF. No, it's still undefined.
What the heck? That's not what's happened to me. It gets signed to a really weird function.
So you did
Wait, what value are you using? What I found is, for whatever reason, in Firefox, if I just did a variable like X, it already had some assignment. So that's why I was doing ASDF, just so you know.
Yeah, I'm not
Okay,
getting
let me try.
that either, Joe.
So I do var ASDF. Hey, let me try a new window. Now I have to know. Var ASDF. It's undefined.
Undefined, right. And then if you do ASDF equal 5 or even double equal 5, you'll get false. But if you do ASDF, you'll still get undefined.
Oh yeah, I do. So yeah, maybe I did something that already had a value and it kind of did the whole prototype thing back to there.
I think that these debuggers already have some variables that have values in them. And so if you're just doing a generic variable, because I tried X and it was coming back with something, I was like, wait a second, I didn't assign anything. So that's why I went with a just random variable name.
Okay, hey, I learned something.
Yeah.
All right, so so undefined is a type, and null is also a type. And what were you saying about that, Owl? You said the difference there is that null is if it's typed.
Null is not a type. Yeah, null is a value. It is not a type.
And undefined is the absence of the type.
Correct.
Okay.
If you do type of null, you get object. If you do type of undefined, you get undefined. Null is actually a value. Yeah.
So if I look at Mozilla's website, it has null listed as a data type. The null type has exactly one value, null. So it's not that it's literally the value null itself is type. So try doing type of null.
Yeah, you get object.
You get object.
Mozilla, you let me down. Yeah, I got object. So, okay. Well, someone hopefully can leave us a comment and let us know what that's about.
Yeah, I mean, the beauty to all this stuff is because JavaScript is just so open and you can do whatever you want. All you have to do is open up a debugger like Firefox debugger, Chrome debugger, and just start typing stuff, and you'll find out all kinds of crazy stuff.
Value null represents the intentional absence of an object value.
Yep. But they're saying it's a type or no?
It is one of JavaScript's primitive values. Oh, it says primitive value, not primitive type here.
Yeah, there you go. Value.
That's funny.
Yeah.
So in the page I was looking at, they actually mixed primitive types and primitive values.
Yeah, that makes more sense.
And well, no, they got it listed under data types too. Anyway, I think we're going to have to move on here because I'm going to spend all day thinking about this. Yeah, it's really weird though. Yeah, they have it.
I want to hear some more weird ones though.
Okay, I think we have one or two more weird ones.
Okay, well, while you're doing that, I'm going to get another joke ready. How's that?
All right.
To developer, this one is thanks to, I hope I'm pronouncing this right name. This name right? Farhat Ozkin.
Oh yeah, Firo.
Two developers walk into a bar and order an API. The bartender asks, "Which one of you is JSON?"
I like it. That's awesome.
Very nice.
I told you they were going to be dad jokes.
Yeah, I appreciate it. I got my spreadsheet back up here. I guess I crashed my browser by overwriting the value of X. So maybe there's some modification or something. Just messing up.
You didn't know it was so easy to destroy Chrome, did you?
No. Let me see here. Yeah, X is a function. So that's exactly what happened there. So in Google Drive, X is defined as a function. So it's probably like minification.
Oh, that's funny. I'm also in Google Drive, and that's when I F12'd, and that's why. Yeah, dude, there's all kinds of crazy functions in here.
Okay, so did you? Okay, I'm sorry, I got to geek out on this one thing for a moment. So when you were like brought up your dev console, then you stayed inside of a Google Doc.
Yep.
Did it?
Yep.
Okay, that's why I didn't have the problem because I opened up a new tab.
That's funny.
And was playing with the console there, and I'm like, man, I don't see the problem they're getting with the X already being defined. But now I understand.
Yeah, it's really funny. When I did var X, it did go ahead and override it, and so it showed null on the console. But then later, after I did the if, I don't understand why this happened. After I did that if, for some reason, when I looked at the value a second time, maybe the var was out of scope. I don't know what happened there, but it defaulted to the original value.
Did you accidentally do equal instead of double equal?
No.
Nah.
I didn't set it to 5. It was the function, this weird function.
Oh, yeah. Yeah, man, that's hilarious. You overwrote something that was core to Google Docs with X.
It crossed my spreadsheet. That's why I went back to it. I was like, hey, wait a second, where did my screen go?
We never said that doing it live was safe.
Yeah, never do that.
So let that be a valuable lesson to anyone who's like going to try to do live coding. And you're like, hey, let me just bring up a JavaScript console. Always do it in a new tab.
Yeah, open a new tab, then hit F12 or Command Alt I.
Yep. So we got one more type to talk about in JavaScript, and this is a new type in ECMA 2015. And I have no experience with this, so this is going to be rough. I'm just going to try and read here, and hopefully we'll figure something out. This symbol is used for metaprogramming. It's a unique-ish immutable value that can be used as keys for objects that are not returned by normal looping or reflection mechanisms. The idea here is that if you're like a framework programmer, you can do some funky stuff to tag and add additional information to your objects and not have to worry about someone doing like basic normal JavaScript looping and ending up kind of accessing your keys and having this weird stuff show up when they're kind of looping over objects.
Wait, what symbol is this?
This sounds familiar.
Symbol is the type.
Type. Yeah, I see it.
And Ruby has symbols, but it's totally different thing here. This is specifically designed for safe metaprogramming. So if you as a framework developer want to take an object and stuff some additional information in there on this object to kind of tag it with some like metadata, do some other funky stuff in the framework and like use that information at a later time, then you can use these symbols as like unique identifiers. It's kind of like generating GUID.
Wait a second. Hold on. I'm not fully following this because I'm over here hacking on the console. And if I do type of symbol, I get function. And if I just type in symbol, it tells me it's a function. I don't know what this function does.
Yeah, so it's kind of quirky. I'm not up to the I am not too familiar with these details. But if you call symbol and assign it to looks like a method, it should generate a unique key that can be used. This is just weird stuff, man.
Yeah, I don't know if I'm spelling it wrong or what, because it's such a complicated word to spell.
Yeah.
But like I do type of symbol and I get undefined.
Oh, hold on. So no, symbol, capital S. So
yeah, but the documentation refers to lower.
So check this out. So we can do var, call it my private method equals capital S symbol.
Yeah.
Okay.
Yep.
Now, if you do type of that variable my private method,
you
get symbol. All right.
Yep.
But if you just try to like show it in the console, it's not very interesting. It just shows like the function that you assigned it to, which is weird.
I mean, I get why it's returning function for the uppercase that you did, Alan, because that's a function that's returning the type.
Right. It gives you back a type symbol. It's really bizarre. I want to look this one up now to see what it does because I have no idea what the use of this is.
Yeah, so the trick then is you can use this as the key in an object. So now you can say like this object, index, so the square bracket, my private method.
Oh, so it's almost like a unique, it's almost like a GUID type thing for your particular object.
Yeah. So I do this brackets my private method, and now I say function, and I'm gonna just alert.
Interesting.
My name.
Okay. Yeah, because I did var blah equal symbol capital S, and then I put A in parentheses, right? and or a quotation A, and then afterwards I have blah. And if you just type in blah, it'll come back with symbol open paren A close paren. So that makes sense for what you're saying. It's like a key that you can plug into some sort of hash.
Yeah, and it's just like any other key, except the distinction is when I say like for var I in object, this is never going to show up. So it's like a secret key. It's hidden.
So
and the only way for you to access this is to basically know about it ahead of time and specifically look for it.
Okay, interesting. So if I say var my obj equal, all right, I'm not going to do this while we're recording because it's just going to be really boring for everybody. All right, but I see what you're saying. So if I added that as a property on my object, and I also have property first name, last name, and I did it for each, I would see the first name and last name, but I would never see my symbol as one of the keys that came out of it.
Right. And my understanding is that that's important for JavaScript because a lot of times you're like dealing with, say, like the DOM, and in HTML you can add arbitrary elements, right? There's no like kind of restrictions on what you can put in there. So you'll see people do stuff on like a HTML element like body or div or something, and they'll have like the rel attribute to kind of reference some sort of data, or maybe they'll do a data tag. There's nothing stopping you from adding any kind of tag you want in that DOM and then referencing it via JavaScript. So if you're a framework writer, you've got to start thinking, if you're interacting with the DOM, like, well, what's reserved? What should I hold back? Like, what do I have to tell people? Don't use these words. Don't use these attributes because I'm using them for some sort of stuff I'm doing in my framework. So rather than saying like, okay, here's some magic words that you have to go look in the documentation to know to avoid, you can do this symbol trick, and you know that unless somebody is declaring the symbol in the same way that you did, that they're not going to end up exposing or bumping into your objects, your keys.
Now, to one point though, Alan, you were talking about like iterating through the properties on the object, but you can get the symbols from the object. So I'm reading another article, they're not private.
Right. Yeah. They're hidden. Like you have to go looking for them.
Well,
they're not hidden.
I don't even know that I would say they're hidden.
They're not, because I can see
they're not
it.
properties.
Right.
So you're not going to see them by like getting the properties, but you can see them by getting symbols. So
yeah. So yeah, hidden is not a good word, but they don't show up in the loop like the normal like for var and like the kind of like the normal functions that you usually use for like iterating or whatever.
Right. So I'm showing right now, I've done this, like I basically added things where I had just, blah as a key and then the symbol as the value. And then I also just went and forced in my symbol as the key. And then I put a value on it, right?
So your giant 34-inch monitor is being represented on my tiny little MacBook screen. So,
and we're translating that to listener ears.
You mind zooming in?
But the interesting thing here is that if you dump the object, you'll see all those. But what Joe was saying is if you're just using a regular iterator on the object, it's going to ignore that symbol. So it's interesting. It doesn't hide it from somebody. So people that are doing frameworky type work, you're still going to be able to see that. But it will sort of safeguard you from accidentally using the key.
Yeah, it's kind of got it segmented off into its other own kind of area to help protect it. It doesn't seem that useful to me, so I'm sure I'm misunderstanding something, and you can let me know in the comments. That'd be great.
Yeah, pretty cool. So yeah, we've all learned a little something here.
And isn't that crazy? That's there's no primitive type for that in Wikipedia, right? Like that's just like, I don't know. It's just weird. There's nothing like that in the article about it. So this is one of those gray areas where like a language in the real world is very popular, is doing things in an incredibly different way than people traditionally think of languages in general.
You know what's crazy is we did talk for over 2 hours about primitives.
Yeah.
That's shocking.
Well,
honestly.
Okay. Hey, I found a good article that might be of interest to you. So like you were talking about the use for the symbols, but it was saying like where you might normally use a string or an integer, like think like an enum kind of a thing, then a symbol might be of more value to you there. So like log level debug, log level info.
Huh.
Yeah, I'll put this article in the doc
Okay.
Excellent.
and then that way everybody can follow along. And if you don't already know, you can normally read the show notes within your podcast player and follow along.
Definitely.
I say normally because not all podcast players are created equally. So depending on which podcast player you use, maybe it doesn't include it.
Yeah, especially the Google one. It's really kind of stinks. I was hoping to try that one out, but it really just truncates all show notes. So
I think Overcast does the same.
Yeah. So we leave a link in there so you can click to them and to get to them. But if you're using a really good podcast player, you'll just be able to see them. So
yeah, judgment. But now that you made it awkward,
right. Oh,
yeah. This article is like all this has a bunch of links and stuff that we talked about, and also all articles and everything that you can find more information about. A few things I wanted to mention here on our way out. In C# said everything was an object, but I forgot that interfaces and pointers are not children of system.object.
Good call.
So that's kind of a weird distinction there, and it has a couple side effects, but for the most part, you don't really have to think about it too much.
We were going to get some comments on that anyway, so that was a nice save right there at the end.
Yeah. Woo!
Yeah. Hey, wait, we're about to miss my favorite. Oh, wait, hold on. Keep going. You have more here.
Okay. So, another thing is just like, if we're really taking these guys as being like the kind of the basic building blocks, like why wouldn't it just be like object and pointers? And actually in C#, there's a property on all types that's called is primitive. So you can actually do type of like int or type of my custom class, and dot is primitive, and C# will tell you whether it considers it a primitive or not. So I thought that was kind of interesting. And to me, it's one of those things that's like the distinction is kind of weird. Like, what does it matter if it's really a primitive or not? And anyway, I just thought it was kind of interesting. And did I just realize that I missed a type? No. Okay. Whew. I thought maybe I missed something. Yeah, got to go back to the beginning.
So complicated.
Right.
Consider this a hint for next episode or something interesting that you should check out. I'm not going to tell you what it is. Yeah, so anyway, I just thought it was pretty cool that there's a is primitive type. And I couldn't really find a definite answer on like what kind of they used to make that distinction. Like why did they say this is true and this is false? But I think it just kind of ties to the how it was originally written and what things kind of map to whatever language they originally written in, like C or C++, even though now it's written in C#. The C# compiler is written in C#.
That's so sweet.
And that's about it. There's a lot more you can kind of dive into on all these basic primitives, and then you can go even further. If you start looking at like arrays in JavaScript, like it's a whole nother ocean. It's not a primitive, it's built in, but it's just kind of cool to think that there's really so much there to know about the languages that you work with day to day. And even though you don't necessarily need to know all the details, there's still a lot of interesting stuff that comes out of it. And it helps you understand some of the quirks that do exist and kind of why they are the way that they are.
Definitely. Hey, and now it's time for my favorite part of the show. It's the tip of the week. And Joe, with that, I think you have the first one here.
Yeah, so I'm kind of doing a double header here. First, got to tell you about something that Mad Viking God set up. Thank you. If you go to codingblocks.net/tips, that will take you to a Google form where you can add a tip, throw your name in there, however you want to be referred to. And we're going to start picking from those guys, from those things in order to have tips. Because I know I particularly am bad at coming up with tips. And I see so many good ones and I lose track of them and I'm bad about remembering who said what. And so I just don't say them. So now what you can do instead is if you've got a tip that you would like to share, you can go to codingblocks.net/tips, pop it in there, and then I'll be scouring that for tips.
Yeah, he hasn't handed out the access to that doc yet. I will point out.
Yes. Wahaha. So only me and that fucking guy can see those results right now. So that's how it's gonna stay.
I can't see the results.
Nope. Nope.
Guess I don't get to use it.
Nope. So codingblocks.is/tips. And I wanted to go ahead and grab one out of there. So big thanks to Brian MMO2 for this tip, which I had not considered. But if you ever had two instances of code open, like Visual Studio Code,
Always.
and it gets confusing because especially with the dark theme, I don't know what it is about it, but I get really confused as to which one's which. Like they are set up the same way that like I don't know what it is, but for whatever reason, I always get confused about it. What I didn't realize is that you can change the status bar color that's stripped down there at the bottom. And we'll have a link to that in the show notes. So you can have one being that cool blue color and one being red. So if these are things that you keep open often, then you can do that. And it's a good way of kind of knowing the difference quickly without it being too distracting.
I like
So
that.
are you saying that you have to like predetermine like, hey, this project is blue, this project is red? Or are you saying that it's like as I add in the next color, as I open the next project, it'll just pick another shade?
So you can assign a color, and it saves it in that .vs code folder, like kind of at the project-ish level. So if you've got things that you open up commonly, then you can do that with the Workbench color customization.
Very nice.
Very cool.
And I'm sure there's a plugin that will automatically do it for you. It seems like there's a plugin for everything.
Yeah. There are plugins for everything nowadays. But most excellent. All right, so mine, I am also borrowing from a listener who just recently commented on episode 87. I don't even remember what that episode was about now, but I saw the comment and I went in there and replied to it. And he was saying, you guys are crazy writing Git commands on command line, which to that I respond, we are crazy, but we are crazy in love with those Git commands on command line. It'll be hard to pry those out of our dead cold hands. But he was saying that he's actually shown other people this one called Git Kraken, which is GitKraken.com. And he said that he's actually had people convert from command line to using that because it's so good. So I haven't tried it out yet, being brutally honest. I may at some point, but I do love my command line. But if it's good enough to convert some people, then it's good enough to recommend. So definitely go check that one out. And big thanks to Lee Odes. So appreciate that. Oh, and it's cross-platform, by the way.
What's the isn't there like an emoticon for like the skeptical face, like the like, you're really going to give me the switch from command line? Like
That's a pretty bold statement. He said it was like the Visual Studio Code for people who are Vim people, showing them Visual Studio Code and then being like, oh, I get it.
Yeah.
So yeah. All right, what you got?
That's going to be a hard sell for me. I'm not going to lie. I can't lie to you. But appreciate the suggestion. Yeah, so I got two I wanted to share. One was that Michael Tippett that we referenced earlier, there was conversations that we had about before in the past. I don't remember the episode specifically, but where we talked about having to test for multiple users, in an environment. And I think I'd referenced something about like I maybe even included as like a previous tip of the week or something.
I think we have, yeah.
Where because I think I remember specifically calling out how like someone on a QA team showed me this trick where they were able to create a shortcut that would automatically like launch into it as a different user or whatever. But Michael pointed out, and I don't know why we hadn't thought about this, because actually I know you use this feature, Alan, but you could create multiple profiles in Chrome. And he pointed out, if you use the manage people feature inside of that, you could have those set up as different accounts. And I thought, oh yeah, it's a pretty good idea, a good way to, solve that. So I should, thought it would be worth sharing. that, if you are in an environment where you need to test a web app, obviously, for multiple users, then that might be a good workaround for you. And then another one that I wanted to share quickly was getting started with SQL Server machine learning services. So starting with, I want to say it was 2016, SQL Server 2016, I believe, they included support for R. And then with 2017, they included support for Python and R services, where you could where you could run Python or R code from a SQL command, right? And then with the upcoming 2019, they've even expanded on that further, where I want to say it's like Spark, I think this is what they were adding. I don't remember, but the this link that I'm going to have in the show notes for the getting started with the machine learning services as it relates to 2016, 2017 for Python and R will show you what you need to do to get your environment set up so that you can use these new features and run Python directly out of SQL Server. And it's pretty cool. You run you'll do a select and it'll return back that data table as a pandas data frame, for example. Right?
Crazy world we live in.
Absolutely.
Yeah. So it's pretty neat. So if you haven't already tried writing Python in SQL Server, here you go.
Most excellent.
All right. Well, with that said, we hope you've enjoyed this deep dive on primitives that I don't think any one of us thought would be quite this long or in depth, but it is.
Yep.
So with that, subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. If you haven't already, as Joe mentioned earlier, we would greatly appreciate if you left us a review. You can head to www.codingblocks.net/review. You can find some helpful links there.
Yep. And while you're up there, check out all our show notes, our examples, discussions, and more.
And send your feedback, questions, and rants to the Slack channel at codingblocks.slack.com. And don't forget those tips at codingblocks.net/tips. You can follow us on Twitter at codingblocks, or head over to the website and you can find all our social links there at the top of the page.